Hello students, welcome to the class. So today is our day 18 of this JEE 40 days crash course and we will cover the rest of the part of this chapter, chemical kinetics. In the previous class we have come to know about the rate of a reaction and about the rate law. Then after we have also studied about the zero order reaction. So we have studied both the differential and integral form of that zero order reaction. Now moving on to today's lecture. So this is our disclaimer. What we will be studying. So first of all, we will study the differential and integral form of the leftover ordered reactions. That includes your first order and your second order. Then after, we will move on to Arrhenius theory. So far, we were concentrated about the concentration effect on any given chemical reactions rate. Now we will see the effect of temperature on the particular reaction. Okay, so this will be our second part. Now, what are the mathematical equations that are used to quantify the concentration effect and the temperature effect on our rate of a reaction? So the rate law is the equation which help us to quantify the concentration effect on a rate of a reaction, whereas Arrhenius theory or the Arrhenius equation help us to quantify the effect of temperature change. So we will be studying that also. Then after, we will move on to collision theory. So this is basically a way to define the Arrhenius theory. Means the equation that is obtained in your Arrhenius theory. So that things come from your collision theory. Okay, so these are the topics that we are going to cover today. So if anyone who has a doubt in the previous class can just post it here in the comment section. So starting with the first part, which is integrated rate equation for first order reaction. Now, to get the integrated rate equation for first order reaction, first you should know that how to write the differential rate equation for that particular ordered reaction. Now, what is the way to write it? It's very simple. We know that rate is directly proportional to the concentration of the reacting species raised to the power 1. Why raised to the power 1? Because the order is 1. Now, if I just write it in terms of mathematical form, so for first order reaction, considering this R going to P, so R is the reactant and P is the product, then we can write from the rate law, rate is equals to minus dr by dt is equals to kr. So what is k here? We have seen this in the previous class. K is the rate constant or the specific rate of reaction. When do we use this specific term? When we are keeping other parameters equals to unity. So here we are taking the concentration of R as unity, then we will see that rate will be equals to K. So that is the reason we called our rate as specific rate constant. And look upon the power of R, the concentration power of R, it is 1. Why it is 1? Because this is a first order reaction. Next, to get the integrated rate equation, we will simply integrate this given differential equation. For that, first of all, we will separate the variables. So here we have dr term. Therefore, we will bring this concentration of R term on the left hand side. Then we will move this dt with k. That will give you minus dr by R is equals to k dt. Then we will just integrate the equation. If you integrate the equation from limit a to a minus x, then you will get your final integrated rate equation for the first law. So it will give you t is equals to 2.303 by k log a by a minus x. What did I say? That we are integrating from initial concentration a to final concentration a minus x, which is being changed in time t. Okay, so starting from 0, we moved on to time t. So t is the time here, a is the initial concentration and k is the rate constant. Then A minus X will be the concentration of A after time t. This means that X amount of your reactant is being consumed. So final concentration is A minus X. So I would suggest you to just try this integration by yourself. How are we getting it? Suppose you bring this R, which is your reactant's concentration, from the right hand side to the left hand side. So it will go on to the denominator. So that will become dr by r. Now integration of dr by r gives you ln r, which is natural log of concentration of r, whereas the k dt will give you t. Very simple. Integration of dt will be t. Now what you will do? You can just take ln r as 2.303 log. So your equation will become minus 2.303 log r is equals to kt. Then you put upon the limit. Limit will be for time. Time will have a limit from 0 to t, and your concentration will have a limit from a to a minus x. So it basically means that in t time your concentration is decreased by x. So if A is the initial concentration, therefore your final concentration will be A minus X. Is it clear to you? Any doubt in this part? So I would ask to write the zero order reaction, if you remember the zero order reaction, integrated form and the differential form. So the most important is the integral form. So please write it in the comment that what is the integrated form of the zero order reaction. So this is for the first order reaction. You will do the same thing in the zero order reaction, and in zero order reaction the derivation is quite easy. There you will get minus dr by dt is equals to k. Since r is raised to the power 0, therefore the term will become 1. So just try it out by yourself and see that what is the integrated rate equation for zero order reaction. And what will be the limit that you will take? Again, you can take it from 0 to t, and you can take the initial concentration as A and final concentration as A minus X. So in that case, what will be your integrated rate equation for zero order reaction? Anyone? Please write it quickly in the comment section. So these two rate laws are very important. You will not see a question often from the second order reaction, but you will always see questions from this zero order reaction and your first order reaction. Okay, so that is for sure. Anyone who got the answer for the integrated rate equation of zero order? And one more thing, can you tell me the unit of this k? You can use this rate law to get the unit of k. It's very simple. K will have a unit of rate divided by concentration of R. So rate has a unit of mole per liter per second, and your concentration has a unit of mole per liter. Okay, so just try this thing also. What will be the answer? Just tell me what will be the integrated rate equation for zero order reaction, as well as a unit for your rate constant for a first order reaction. Anyone? Okay, so I am moving forward. You can just comment it here. Next, upon completing this first order reaction, now we will see the half-life of this first order reaction. Again, what is half-life? We have discussed it in detail in the previous class. It is basically the time which is required to make the initial concentration half of its value. Means if R naught is the initial concentration, your concentration after half-life will be R naught by T. Okay. In the previous equation that we have seen right now, in that case your initial concentration was A. Therefore, after half-life your concentration will become A by 2. Now if you just put as final concentration your A by 2, then you will get it as T is equals to 0.693 by K. Since we are finding it for half of the concentration, therefore your time will be equals to T half. So this is basically a way to represent your time in case of half concentration involvement. Okay, since half of the concentration has been consumed, so now you replace your T with a T half concentration, which is representing that this time is your half life. Now this equation is very important, and it tells us a very important thing, that your half life is not dependent upon the initial concentration for a first order reaction. Okay, so for a particular reaction you will always get the same half life independent of the initial concentration that you have taken in the start of the reaction, because your T half is only dependent upon K, which is a constant. Therefore your half life has no change upon changing the initial concentration. Whereas if you consider the half life for your zero order reaction, the equation comes out to be T naught is equals to C naught by 2K, where C naught was the initial concentration. So from there we can easily see that your T half is directly proportional to initial concentration. If you keep on increasing the initial concentration, the half life will increase, means the time required to consume half of its concentration in case of zero order reaction increases with initial concentration. But in this case it is constant, it is not dependent upon the initial concentration. Next, what will be the unit? It's very simple. You can get your unit from this equation also, since time is a unit of second, and from dimensional analysis you can clearly say that T half and K will have the same unit, because this 0.693 is a constant. Now when it can have the same unit on both sides, when you take the unit of K as per second, when this per second will go into the numerator, that will give you your unit as second. So you can either derive it from the rate law or from this equation. You will get the same answer. Okay, I hope this is very easy to understand. Next, for any reaction we can have a general equation for getting our half life period. And what is that equation? It is T half is directly proportional to 1 by A to the power n minus 1, where what is A? A is the initial concentration and n is your order of reaction. Okay, so this equation is very important for seeing a relation between your T half and your nth order reaction. So if I ask you what will be the connection between your half life and your second order reaction, then what you will do, you will simply take this n is equals to 2. Therefore your T half will become inversely proportional to A. Got it? Then you can also take the example of a zero order reaction. If you keep here the value of n as 0, that means your T half will be directly proportional to A. And if you take the value of n as 1, in that case your T half will be independent of A. So this is a very important equation to relate your half life with your initial concentration, given your order is known to you. Anyone who has a doubt in this? Is it clear to all of you? So far we have studied about the zero order reaction, the first order reaction and their half life. Now we have introduced a general equation to know the relation between the half life and the initial concentration. The equation goes as T half is inversely proportional to A to the power n minus 1, or T half is proportional to 1 by A to the power n minus 1. Now depending upon the order of the reaction, that means your n, your T half will vary according to the initial concentration, which is A. Next, moving on to the other part of the first order reaction, which is for gas phase reactions. So if we take a reaction of A going to B plus C, where all the given species are in gaseous state. So in this case, you can have your integrated rate law in terms of total pressure. So the equation is not changing here. Okay, so this is very important to note. So some student make a mistake of seeing that this equation is different from the general equation of integrated rate law of first equation. Okay, first order reaction. But there is no change. Here in the above part we have the initial concentration, in the below part we have the final concentration. Only the difference is that here we have taken the final concentration in terms of initial concentration and your total pressure. Means this reaction must be going on in a particular vessel, and that particular vessel must have a pressure which is simply the partial pressure, which is simply the addition of partial pressure of each of these gaseous species. So this equation you are seeing right now is the way to calculate your rate constant in terms of initial pressure and your total pressure, given that you know the time. Okay, is it clear to you? So this equation is very, very important. Next, what are the terminologies that we are seeing here? So first one is P naught, which is your initial pressure, and PT is the total pressure after time t. What is total pressure here? Again, I am repeating it. It is the addition of the contribution from pressure of A, pressure of B, and pressure of C. So this PT is representing the total pressure of these three species in the overall vessel in which you are carrying out your reaction. Okay. Now, this equation may change according to the stoichiometric coefficient that you are considering. Means if there is 2A, you will get a different equation. So I am leaving this to you to try to derive an integrated rate law equation for a first order gas phase reaction, but in terms of total pressure. Next we have second order reaction. So second order reaction is as simple as your zero and first order. Here what we do only small change, that the concentration is raised to the power 2. So in zero order it is raised to the power 0, in first order it is raised to the power 1, and in second order it is raised to the power 2. Now if this is true, then we can write the rate equation or the rate law as K is equals to 1 by T x by A into A minus x. So this is your integrated rate law for a second order reaction. So rather than deriving it again and again, I have directly written it by integrating the differential rate law for the second order reaction. If you integrate that thing and you take initial concentration as A and final concentration as A minus x, which is after t time, you will get this same equation. Okay. So you can try it by yourself, and if you have a doubt, you can just come and ask it in the doubt session that we held from 10 a.m. in the morning to 6 p.m. in the evening. Now, remember, in this in this second order reaction, all the reactants are same. So we have only one species that is present in the reactant side. Then and then only this equation is applicable, right? Because we are seeing the concentration change for one species only. So A must be the concentration, initial concentration of that one species, and A minus x is that final concentration after time t after that particular species. So what I am telling here is that your reactant is same. Okay, only the concentration is raised to the power 2 for that particular given reactant. Okay, so we are not taking two species here, A and B, for second order reaction. Okay, so that is also possible. We can have a second order reaction where we have two reactants, but remember here we are taking the same reactant or one reactant, and that reaction is still a second order. Now what will be the unit of this? Very simple. You can again use our general equation. It will give you mole inverse liter second inverse. Okay, anyone who has a doubt in this? So let me tell you what is the general equation to get the unit of rate constant. It's very simple. So mole raised to the power 1 minus n, then we have liter, then we have per second. So liter is raised to the power n minus 1. What did I say? You can find easily the rate constant unit for any particular reaction of any order. And what is the general formula? Mole raised to the power 1 minus n liter raised to the power n minus 1 per second, where n is your order of the reaction. So if you put n is equals to 2 in that particular general equation, you will get your power for mole as minus 1, for liter as 1, and second will have no effect or no change due to change in order. So it will always be per second. I hope this is clear to you. Now moving on to the next part, which is pseudo unimolecular reaction, or you can tell it as pseudo first order reaction. So what is pseudo first order reaction? Basically, pseudo means it creates a wrong idea about the equation, that this equation is a first order. And what is the reason behind creating that illusion? The reason is that we take the concentration of the second species in a very large amount. As a result of this, the change in concentration is very much minute as compared to the other species whose concentration is changing. Therefore, you will see that there is no effect of the concentration change for the second species, and it is only dependent upon the first species. As a result of this, we see a pseudo unimolecular reaction. Now, can we take an example of it? Yes, we have hydrolysis of ester. Now, in hydrolysis of ester, we use water as the second reactant. We also call this pseudo unimolecular reaction as pseudo first order reaction. So this is the equation for a particular ester being hydrolyzed in acidic medium. Now here, if you write it in general, means if you consider the actual rate law for the given equation, it will be rate is equals to concentration of your ester multiplied by concentration of water, where both of them are raised to the power 1. But what happens that your concentration of water is in excess, and therefore change in concentration is negligible. Therefore, in the final rate law, we only take the concentration of ester, which is a primary factor or important factor for determining the rate, and not the concentration of water. Okay. Now a very important thing. Children make a mistake or find it confusing that which integrated rate law should you use for pseudo unimolecular reaction. So remember, this is very important. Whenever you see a pseudo unimolecular reaction, then you always use your first order integrated rate law to solve its question. I hope I am clear to you. Again, I am repeating it. So whenever you are given in the question that your given equation or your given reaction is pseudo unimolecular reaction, then in that case you will use the first order integrated rate law to solve its question. Got it? Because your given equation is acting as a first order, therefore you will use the integrated rate law of the first order reaction. I hope this is clear to you. Anyone who has a doubt in this part? Okay, now moving on forward. So we have dealt about the concentration effect on the rate of a reaction. Now we will move on to temperature coefficient. Okay. So basically, temperature has a large effect on any reaction. Consider the concentration of the product form or consider the rate of the reaction. Both are affected by the change in temperature. Now it is seen in general that for a chemical reaction, we see a reaction rate doubled upon increasing the temperature by 10 units. Okay, now it can be both in Kelvin and degree Celsius because change in temperature has no units. You can take it for both Kelvin as well as degree Celsius. So what did I say? For 10 unit rise in temperature, either in degree Celsius or in Kelvin, the rate of a reaction always gets doubled. Suppose it is initially 2 into 10 to the power 5 mole per liter per second. So if you raise the temperature by 10 degrees Celsius, your new rate will be 4 into 10 to the power 5 mole per liter per second. I hope this is clear to you. So this is very, very important. Now, this doubling that you are seeing, this is basically your temperature coefficient. Means for each 10 degrees rise in temperature, what is the factor by which your rate of reaction has changed? So if it is changing by 2, then your temperature coefficient is 2. But in some cases, you will also observe that this value can also go greater than 2, or it can even reach to 3. So in general, we can conclude that for 10-degree rise in temperature, normal chemical reaction or generally all chemical reactions show a change in rate by doubling it from the initial part. But it can also increase from 2 or even move to 3. And this doubling or tripling that you are seeing upon increasing the temperature by 10 unit is the temperature coefficient. So if it is doubling, that means your temperature coefficient is 2. If it is tripling, your temperature coefficient is 3. Now, moving on to the Arrhenius equation. So right now we have done a discussion of temperature dependence, but that discussion is somewhat very ad hoc. It is not appropriate or has it does not have a particular specific equation. So to deal with it in a specific manner, we apply this Arrhenius equation. Means what is the exact change in your rate constant or your rate law upon changing the temperature. So this thing is seen with the help of Arrhenius equation. Now this is also a very, very important part, as it totally defines the effect of temperature change on any chemical reaction. It says that your temperature dependence can be defined with the help of Arrhenius equation, and that thing is K is equals to A e to the power minus EA by RT. We will move on with the equation and try to define each terms one by one. So let me just tell the name of these equations. Next, okay, so we can do one more thing here. We can just take log on both sides. Okay, 2.303 log on both sides, and if you just bring this equation further, it will give you log K is equals to log A minus EA by 2.303 RT. How do we get it? So it's very simple. First of all, you take ln on both sides. So ln K, ln A e to the power minus EA by RT. Now we know that ln A into B means if two terms are multiplied within the ln bracket, then we can write it as ln A plus ln B. So we can write ln A e to the power minus EA by RT as ln A plus ln E to the power minus EA by RT. Next, ln E is equals to 1. Okay, ln E is equals to 1, and raised to the power minus EA by RT can go to the back side. So basically ln A to the power x can be written as x log A. So this is a difficult log operation. You can just try this in your notebook as well. So simply use three equations here, three properties of log. First property, ln A into B is ln A plus ln B. Second property, ln E is equals to 1. Third property, ln A raised to the power x will give you x log A. If you use these three properties here, you will get this final equation. Next, what are the terminologies here? So this is important to remember. K is your rate constant that you are seeing so far in the rate law. That same rate constant is here. Next, A is the Arrhenius constant or frequency factor. We will study about this in the upcoming slide when we will move on to the collision theory. Then we have this A, which is the activation energy. If in short, if I tell you what is this activation energy, this is basically the energy required by the reactant molecule to convert itself into the product. As simple as that. Okay, this is the highest energy required by the reactant molecule to go into the product form. So this is your activation energy. Now if you take this equation and try to plot a graph, what it will give you? So compare this equation with the equation of straight line, which is y is equals to mx plus c. Now y will be log k. So here it is written log k. Then mx. mx means m is your slope and x is your x coordinate. So we take x as 1 by t. Then what are we left with? We are left with this minus EA by 2.303 R. So that will be your slope. So we have written it here as slope. Then here you can see that this graph is intercepting the log k coordinate. Now this will be your intercept and it will be equals to log a. Okay. So this value that you are seeing right now is your log a. Got it? Any doubt in this? So this graph is very, very important for you. What you have to do is to simply equate this given equation with the equation of straight line, which is y is equals to mx plus c. You will get your y as log k, m will be your slope, which is minus ea by 2.303 r, x will be your t, and c will be your log a. Okay, your overall log a will be your c, and c is what? It is the intercept on y axis. So this point that you are seeing right now, where the slope has intercepted your y axis, this is your log a. Any doubt in this part? Is it clear to all of you? How we moved on from this equation to this equation? You can just try this out by yourself. What properties of log you should use? First of all, ln a is equals to 2.303 log a. Second property, ln x into y or log x into y can be written as log x plus log y. Third property, ln e is equals to 1. Okay, so whenever you take the ln as e, it will give you 1. Fourth property, ln a raised to the power x, means your a, if it is raised to the power x, you can write it as x multiplied by log a. And after using these 4 identities of log, you can easily get this equation. Now, moving on further with this Arrhenius equation. So here are some aspects of Arrhenius equation. First of all, it explains the product formation with the help of activated complex theory. Basically, it will not go directly from reactant to product. First of all, it will go to a intermediate form or an activated complex form depending upon the reaction. And the energy which is required to reach that intermediate is your activation energy. Okay. Then next, this thing is based upon the collision theory and the transition state theory. So we will see this collision theory in the upcoming slides. Transition state theory is not discussed because it is not that much important. But collision theory is important because from here only you will see that your Arrhenius equation is derived. Next, we can see aspects of this Arrhenius equation as well. So this EA that you are seeing, it will always have a positive value. So this is very important, note it down. EA will be always positive. It is not possible that EA can be negative, or else your reaction will go on forever, because negative energy means your reaction can be carried out by going to a lower state. So that is something which is not possible. So we can say that EA will be always positive. Now, if EA is positive, then we can easily say that if we increase the value of T, then this whole denominator will increase. Okay. And if this denominator will increase, this value of fraction will go down. But this value of fraction is having a negative sign against it. Means this whole value will go up. So basically, if T will go up, the fraction will go down because it is present in the denominator. If fraction will go down, then this e to the power minus will go up because this power is in the negative form. Got it? You can just analyze it. It's very simple. So the result is almost very important, which says that if you increase the temperature, that means your K will always increase independent of the reaction that you are considering. So we can tell a very important thing from here. What is that thing? So for any reaction, independent of its nature, whether it is exothermic or endothermic, the rate of a reaction will always increase when you increase the temperature. Now question is different. The question is that whether the reaction's forward rate is increased in much more enhanced form or your backward rate is increased. So that will define your product formation. But remember always that rate of reaction will increase. That is for sure. Now, next thing, if you take this temperature equals to infinite, that means 1 by infinite, if it is equals to 0, and anything raised to the power 0 will give you your A. So we can say that when temperature is raised to infinite, then your K becomes equals to A, and this is the maximum value of K. So what we can say, that what is your A? So here you are getting a physical meaning of this A. So this A is the maximum value of rate constant which is possible, and it is only possible at one temperature which is infinite, which is practically not achievable. So what can we define? How can we define this A? So this A, which is our Arrhenius constant or your frequency factor, is the maximum value of your rate constant, and it is achieved at the infinite temperature. Then a very important point here, which is for radical reactions. So we have examples of radical reactions such as chlorination of methane in the presence of UV light. So there we know that radical formation takes place, and radical formation has no relation with temperature, because for those reactions the activation energy has 0 value. Therefore, in that case, your also rate constant is always maximum. Therefore, temperature change has no effect on radical reactions. So this is a very important point here for radical reaction. So two things you should remember. First thing is that if for a given reaction activation energy is 0, that means your rate constant will be independent of temperature. Got it? Second thing, for reactions whose rate constant is dependent on temperature, the rate constant will achieve the maximum value at infinite temperature. So these are the two important aspects of your Arrhenius equation, or two important situations when your rate constant can have a maximum value. Okay, so one is reaction dependent and second one is temperature dependent. How reaction dependent? So for example, for radical reaction, the activation energy is 0, therefore the rate constant is always maximum. For how temperature dependent? So for temperature equals to infinite, the e to the power is taken as 0, therefore the rate constant is always maximum. Now if the rate constant is maximum, that means your rate will be also maximum, because rate law says that rate is equals to K multiplied by concentration. So if your K can achieve a maximum value, in that way your rate can also achieve a maximum value, because they are directly proportional according to the rate law. So we can say that if you are increasing the temperature, you are increasing the rate constant, and if you are increasing the rate constant, you are increasing the rate of reaction. Okay, I hope this point is clear to you. Anyone who has a doubt till this part? So now we will discuss this Arrhenius equation in detail in next upcoming slide, when we will see this Arrhenius equation in action. So basically it is applicable for various temperature, and with the help of this application we can find rate constant at a particular temperature if we know the rate constant value at a different temperature. We will see that aspect. So is this part clear to you? So questions are asked from here in the statemental form. So suppose you can be asked that what is the effect of your temperature if it is made to infinity on the rate constant? What will be its value? Or you can be asked a question that what will be the effect of activation energy if it goes to 0 on the rate constant? Any doubt till this point? So in today's lecture, what we have studied? We have studied the first order rate law, the second order rate law, and their respective half-life, as well as the half-life equation for a nth order reaction. So what is the relation? It is T half is inversely proportional to a to the power n minus 1, or T half is directly proportional to 1 by a to the power n minus 1. Then we have seen that your half-life for a first order reaction is independent of initial concentration, because T half is equals to 0.693 by K. and K is something which is not dependent upon concentration, it is the rate constant. Then also we have seen the rate law for the first order reaction, integrated rate law, which is given as T is equals to 1 by K ln initial concentration by final concentration. Now we have seen this Arrhenius equation, which is K is equals to A e to the power minus EA by RT, where K is your rate constant, EA is the activation energy, which is basically the energy required by the reactant to convert it into product. T is the temperature, R is the gas constant, and A is specifically the highest value of rate constant possible. So it is possible in two ways, at infinite temperature or for the reactions which are having a zero value of activation energy, and the example of that would be your free radical reaction. Now next, moving on to activation energy. So I have defined it earlier. Just see the definition. It is the minimum amount of energy which must be absorbed by the reactant for a chemical reaction to occur. How it is represented? It is represented by E with A in the subscript. Now, some important factors on which activation energy does not depend. So you must remember that if you change the volume or you change the pressure, pressure and volume has no effect on activation energy. And what is the reason behind it? The reason is that your activation energy is something which is totally dependent upon temperature and upon catalyst. So these two things are there that can affect your activation energy. Now, why it is so? Why catalysts help us to change the activation energy? So catalysts are those substances which always increases the rate of reaction. How does it do so? What is the reason behind it? It cannot provide energy to the reacting species. Then what is the reason behind it? How does catalyst increases the rate of reaction? Basically, the catalyst, it provides an alternative pathway. Okay, so take your reaction course way as a hill. Okay, suppose you have to go from point A to point B, and in going from point A to point B, two paths are possible. First path is having a high hilly area. Second path is having a comparatively planar area. Of course, you will take the planar area because that would be easy to undergo. Similarly, your reaction is acting in the same way. It is also very lazy. So, your catalyst, what it does, it provides an alternative pathway where the energy required or the activation energy is comparatively less to the previous course. As a result of this, your lazy reaction takes that lower energy path. And in this way, your reaction rate is increased because now your reactant can be easily converted into product from the easier path. Got it? So, next, on moving on further with this activation energy, we have some more points here. As I said, that catalyzed reactions are faster. So, you can take the example of a catalyst such as enzyme, which is present in your body, or you can take the example of metal catalyst. Both of them provides a lower activation energy, and hence they are very effective in carrying out a reaction in faster way. Next, we have a term known as threshold energy. So this threshold energy is something which is independent of temperature, but EA shows dependence on temperature. What is the reason behind it? So for that, you should understand what is threshold energy. Here we have a diagram. This diagram shows you where is your activation energy, where is your effect of catalyst. Okay, so you can see here that the difference between your energy of your highest point, which is your maxima, and your reactant is the activation energy. So this is the pathway, means this solid line that you are seeing is the pathway provided without catalyst, and this dotted line that you are seeing just below this solid pathway is the path provided with catalyst. What can you observe? You can clearly see that this axis is defining the energy. So the energy difference between the highest point in the first pathway and the reactant point is large as compared to the pathway provided by the catalyst. As a result of this, the rate of the reaction in the presence of a catalyst increases. Okay. So this is basically the difference that your catalyst make upon introduction to the chemical mixture. Now, what is threshold energy? So we are interested in that. So this threshold energy is basically the energy difference between your highest point and the 0 point. So this will be your 0 point here at the 0 point, and the energy that is at the maximum. So this energy you are seeing, this is known as the threshold energy. Okay. Now this will be of course independent of temperature, but this activation energy is dependent on temperature. How? Let me just make it clear. If you increase the temperature, what will happen? Your reactant will gain energy. As a result of this, your reactant's energy will increase. Suppose it goes from here to a higher point here. Now, the energy difference between the highest point of the reaction courseway and the reactant has decreased. That is, your activation energy is decreased. But as compared to threshold energy, which is basically the energy from your 0 point onto the maximum point, this has no effect of temperature change because it is not dependent upon the reactant's energy. Okay. Is it clear to you? So what is threshold energy? This must be clear to you. First of all, it is basically the activation energy plus the extra energy that you are seeing. Any doubt till this point? Is it clear to you? So if you have a doubt, you can just post it here in the comment section. Anyone who has a doubt till this point? Okay. So I hope this difference between threshold energy and activation energy is clear to you, and how temperature can affect the value of activation energy as well. So next is calculation of this activation energy. How do we calculate it? We have seen an equation which relates your reaction rate constant and your activation energy and your temperature. So it is basically K is equals to A e to the power minus EA by RT. So if we take ln on both sides, you will get it as ln K is equals to ln A minus EA by RT. Next, take ln as log and take two temperatures. So define this equation for two temperatures. Now changing the temperature will change the K also. Suppose we write temperature as T1, then the corresponding rate constant is K1. Similarly, if the temperature is T2, the corresponding rate constant is K2. Now if we take both the condition, then we can write it for the first condition as ln K1 is equals to ln A minus EA by RT1. Remember, your A has no effect from the temperature. See, it is still A. And for the second condition also, or the same notation as A. Therefore, ln K1 is equals to ln A minus EA by RT1, and ln K2 is equals to ln A minus EA by RT2, where K1 is the rate constant at temperature T1 and K2 is the rate constant at temperature T2. So one important point you should remember here, that your A has no effect due to temperature change, since at both temperature we are taking the same value of this A. Next, moving on further, we can just subtract equation 1 from 2. If we do so, we will get it as ln K2 minus K1 is equals to minus EA by R T2 plus R EA by R T1. Very simple. This minus sign has been multiplied by the minus sign of EA RT1, and you are getting it as plus EA by RT1. Next, what we can do is we can take this RT1 EA by RT1 on left hand side and minus EA by RT2 on the right hand side, and then we will get this equation, or we can just rearrange it. So we have used the property of log again. So if ln A into B can be written as ln A plus ln B, Therefore, ln A by B can be written as ln A minus ln B. So we have reversed it. So we can write it here that ln K2 minus ln K1 can be written as ln K2 by K1. So this is the property or identity of log. Then after we can take EA by R common from here, and hence we can just take ln as log. So if we take ln as log, so that would be 2.303 log K2 by K1. Multiply this 2.303 here on the right hand side, it will go into the denominator, and finally we get our final equation, and this equation that you are seeing can be also written as d ln k dt is equals to EA by RT square. Okay, so this is another form of your given Arrhenius equation. So it is not defined for two different temperatures. We have taken the initial form of the Arrhenius equation, which is k is equals to a e to the power minus EA by RT. Then we have taken ln on both sides, and finally we have differentiated our equation with respect to temperature, and so we are getting this equation. Now this equation that you are seeing clearly says that if you know that value of EA, the value of rate constant at a certain temperature, so that can be T2 and K2, then you can find the rate constant on a different temperature, which is T1. Okay, I hope this equation is clear to you and how we derived it. It's quite simple. You should know how to integrate and differentiate in this whole chapter, and you should know the identities of log. So that is something which is very important. You can just refer our first lecture of the whole series of our NCRT for this log properties and your integration and differentiation. Okay, so there we have dealt with this basic mathematical formulas. Moving on further, next what we can do, we can also calculate the activation energy with the help of a graph. We have already seen an equation where we have plotted log k versus 1 by t. So what was the equation that we were getting? Log k is equals to log a minus EA by 2.303 RT. In this equation, if you compare it with the straight line as we have seen in the previous part, your intercept will be equals to log a and your slope is equals to minus EA by 2.303 R. So it's very simple, just equate it with y is equals to mx plus c. So mx is this whole term, c is this intercept which is log a, and y is this log k. Next, what we can do, we can easily calculate the value of activation energy from the slope. Since slope is equals to EA minus EA by 2.303 R, therefore EA is equals to minus 2.303 R into slope. After that, this is your slope that we will get upon plotting this particular graph. It's very simple. You can see that this is y, which is log k. Then 1 by t here is the x axis. Then this intercept that you are seeing, where your slope is intercepting your y axis, it is your log a value, and your slope of this given equation is minus EA by 2.303 R. So you can also calculate your activation energy using this graph. Our last point of discussion is collision theory. So as I said earlier, our main equation of Arrhenius is derived from this collision theory, and let us see how it is defined. First of all, if I try to make clear what is collision theory, it is simply saying that your molecules here are considered as hard spheres. Okay, and a reaction will only occur if there is collision. What is the first point that I have made? First point is that all your reactant molecule will be considered as hard spheres, and when these hard spheres collide with each other, then it results in the formation of product. But the point is that every collision necessarily does not lead to the product. When does it lead to product? Let us see that point. So first of all, the collisions which leads to product are known as effective collision, means they are effective in producing the product. So we name those collisions as effective collisions. The first criteria is that it should have a minimum energy. We have seen just right now in the previous part a graph where your reactant molecule must have a minimum energy for the product formation. So that minimum energy is EA. Okay, here we are representing it with ET. So this is with respect to the total energy that is required by the reactant. But since your reacting species have already some energy present in it, so the latter energy which is required, we now name it as EA. So threshold energy is the energy which is required for the reactant, and activation energy is considered since your reactant has already some energy present in it. Now, first thing is what? It is energy. Therefore, your threshold energy is what? It is the activation energy plus the average energy of molecule. Next, this is your first factor, which is an energy factor. What is the next factor? The next factor is your collision factor. How many molecules are colliding? So this e to the power minus EA by RT that you are seeing right now, it is representing that your part of the molecule which is having an energy of EA. What does it represent? This e to the power minus EA by RT, this exponential part is representing that what fraction of the molecule is having an energy of EA. Then this ZAB that you are seeing, it is representing the number of collision. So we are taking different factors and multiplying them with each other to get a complete representation of all possible factors. So two factors we have considered right now. First thing is collision. What are the number of collision that are going on, which is basically collision frequency. Second thing is the energy factor, means the fraction of molecule which is having an energy EA. The third factor is the steric factor. Okay, steric factor means for any given chemical reaction, your molecule must collide. First thing. Second thing, it must collide with appropriate amount of energy. Third thing, it should collide in proper orientation. Okay, when you will move on to chapters like haloalkanes and haloarenes, then you will see SN1 and SN2. So basically in SN1 and SN2, the molecules approach each other in different way. Okay, specifically in your SN2 reaction, where there is a backside attack. So here we have a specific orientation for attack. So that thing is considered here with the help of this P. And what is this P representing? It is representing the steric factor, the probability or the steric factor. So from this we can get our overall equation. What are the factors it depends upon? First thing, it should undergo collision, which is ZAB. Second thing, those collision must contain molecule of enough energy, which is represented by e to the power minus EA by RT. Third thing, during the collision, there must be a proper orientation. Means if your two molecules are colliding like this, then only they will result in product. And if it is colliding in a different way, suppose from the back side, then it will not give the product. Okay. Now, this PZAB is simply replaced by A that you see in the final equation. And this rate is replaced by K. And therefore, we get it as K is equals to A e to the power minus EA by RT. So this is a kind of form of the Arrhenius equation which can be further concluded or simplified to the Arrhenius equation. I hope this is clear to you. So this is all your theory part. Now next we will do questions on it. So just wait for a while. I will move on, open the questions which are the PYQs, and then we will solve. Okay. So here is your first question. You have to say that what is the formula for the rate constant of a zero order reaction. So we have studied this in the previous class. Just give me the answer in the comment section. 4 options are here. First of all, K is equals to C naught by 2T. Second one, K is equals to C naught minus CT by T. Third one, K is equals to ln C naught minus CT by T. And fourth one is C naught by CT. Very simple. If you just remember it, it's very good. If you are not able to remember it, then you can just directly derive from the differential rate law. Okay. So for differential rate law, you will take the rate law as dr by dt is equals to k a raised to the power 0. Sorry, k r raised to the power 0. Okay. So what will be the answer for this question? Anyone? It's very simple. So what you have to do? You have to write the rate constant using the integrated rate law for the zero order reaction. So moving on to the correct answer, it will be B. K is equals to C naught minus Ct by T. So I guess it's very simple. Still, I will give you the initial part. You can just integrate it by yourself to give the correct answer. So this is the initial form. Minus dA by dt is equals to K a raised to the power 0. Yes, Varsha, it will be B. Now next, you will take the initial concentration as C naught at time t is equals to 0. Then time t is equals to t seconds, you will take the concentration as Ct. Put this limit and integrate this thing. If you integrate it within proper limit, after rearranging the variables in this way, you will get the final equation as K is equals to C naught minus Ct by T. Moving on to the next question. Next question is that the rate of decomposition of ammonia is given as 0 order. So you have to tell that what will be the rate of production of N2 and H2 if the rate constant is given as 2.5 into 10 to the power minus 4 mole per liter per second. So it's very simple. You know how to write the rate law, and you also know how to write the rate in terms of concentration change with respect to time. First of all, try to write the equation for the decomposition of NH3. Of course, it will break down into NH3 and N2 and H2. Balance that equation and write the rate law according to the stoichiometric coefficient. Okay. And also write the rate law according to the rate constant. Just equate both of them. It is already given that your rate constant value is 2.5 and 10 to the power minus 4. And this information is enough for solving this question. What you have to do? You have to find the rate of production of N2 and H2. So I am giving you some time to solve it. Try it by yourself and write your answer in the comment section. Anyone who got the answer? So this is your rate constant, right? You know what is the rate law? Rate is equals to K concentration raised to the power 0. Since concentration is raised to the power 0, therefore rate will be simply equals to K in the case of zero order reaction. So you got your rate from here. Further, rate can be written in terms of concentration change with respect to time and dividing it by the appropriate stoichiometric coefficient. Okay. So just try to define it. What will be the answer? Anyone who got the answer for this question? So it's very simple. What you have to do? You have to find the rate. Okay. K is already given. So rate will be simply equals to K for a zero order reaction. From there, you can use the relation between your rate and the rate of appearance of disappearance. which is written using the stoichiometric coefficient. Okay, moving on to the correct answer. The correct answer will be C, which is 2.5 into 10 to the power minus 4 mole per liter per second and 7.5 into 10 to the power minus 4 mole per liter per second. Next, how can we solve it? First of all, we will write the equation, complete chemical equation, which is 2NH3 giving us N2 plus 3H2. Okay. So, what is given in the question? It is given, your rate is given in the question, right? So, rate can be written as in terms of your reactants and products minus 1 by T dNH3 by dt. Why are we taking a negative sign here? Because the concentration of NH3 is going down and the stoichiometric coefficient is 2. Further, we can write in terms of product also, but with a positive sign because the concentration of product is increasing. Here the stoichiometric coefficient is 1, so we will simply take it as 1. Whereas the coefficient for H2 will be 3, so it will be 1 by 3 dH2 by d3 dt. What is given in the question? So from the rate law, we know that rate is equals to k NH3 raised to the power 0. From this equation, we can clearly say that because the reaction is given as 0 order reaction. Therefore, we can tell that minus 1 by 2 dNH3 by dt is equals to 2.5 into 10 to the power minus 4 mole per liter per second. Why I am telling it? What is the reason behind it? The reason is that because K is given as 2.5 into 10 to the power minus 4 mole per liter per second. Since this value is equals to 1, therefore rate is equals to this value. Further, from the first equation, it is very clear that this whole thing, which is in respect to dNH3 by dt multiplied by minus 1 by 2 is equals to rate. Therefore, this minus 1 by 2 dNH3 by dt is equals to 2.5 into 10 to the power minus 4 mole per liter per second. Then after, what we can do? We can also equate this with dN2 by dt, because dN2 by dt is also equals to rate. Therefore, we can clearly say that rate of production of N2 is 2.5 into 10 to the power minus 4 mole per liter per second. So everything is coming from this and this equation by comparing these two equations and using the information of K given in the question. So it's very usual that we take this dN2 by dt as the rate of production of N2. But for the rate of production of dH2, we have to find this value particularly, which is dH2 by dt. How can we find it? It's very easy. Since these two are equal, therefore, if we cross multiply this 3 with 2.5 into 10 to the power minus 4, we can get dH2 by dt and it will be 7.5 into 10 to the power minus 4 mole per liter per second. So 2.5 multiplied by 3, it will give you 7.5. Okay. Easy to solve. Next question. It says that the rate constant of a zero order reaction is 2.0 into 10 to the power minus 2 mole per liter per second. Suppose if I ask you that this zero order is not given, then rate constant is given. Okay, zero order is not given in the question, only rate constant is given, that the rate constant of a reaction is this. Then how can we know that it is a zero order reaction? Very simple, from the unit. Okay, you know the unit of the rate constant for a zero order reaction, try to find it out and you will know it immediately that this rate constant is for a zero order reaction. But what is asked in the question? It is asked that if the concentration of reactant after 25 seconds, means time is given, is 0.5 molar, means the final concentration is given. After 25 seconds, you know the final concentration. You have to find the initial concentration. Options are 0.5 molar, 1.25 molar, 12.5 molar and 1.0 molar. How you will solve it? You will use the integrated rate law of zero order reaction. Then you will put the values which are given in the question. So you are given with the rate constant value, you are given with the value of time, which is 25 seconds, and you are given with the value of final concentration after 25 seconds. Only one variable is unknown to you, which is your initial concentration. Rearrange your equation and you will get your final answer. Just try to solve it by yourself and tell me what will the answer. It's a very simple question. Anyone who get the answer? So Khushi Kumari, D. Let's see what is the correct answer. Okay. So starting with the correct answer. So of course it will be D. How we'll solve it? We know that for a zero order reaction, rate can be written as equals to K because concentration term will have a zero power. Next, what is this rate? It is dx by dt or final concentration minus initial concentration. Okay. Next, this time is given as 25 seconds. Got it? Multiply this thing on the right hand side and you will get your answer as x1 minus 0.5 is equals to 0.5, which can be simply solved to get it as 1 molar. I hope this is very simple. Now you can solve it in this way also, or if you want, you can also use the integrated first law. So that would be more easy for you, right? Or else you can use this way also. You will get the same answer in both the situations. Next question. The time for half-life period of a certain reaction A going to product is 1 hour. Now, it is given that the initial concentration of A is 2.0 mole per liter or 2 molar. You have to tell that what is the time required for getting the concentration from 0.5 molar to 0.25 molar if it is a zero order reaction. So, what will be the answer? Try to solve it by yourself. Since it is a zero order reaction, you can get your K from here. Okay, so it is given in the question that half life is 1 hour. You have to find the answer in hour only. So no need to convert the unit from hour to seconds. You will get the same answer. You can directly start it from the hour part. Okay. Remember what is the formula for half life of a zero order reaction? So what is given in the question? Try to understand that thing first. It is given that if you take the concentration of 2 mole per liter, then the half life comes out to be 1 hour. Now you have to tell that if this condition is true, you have to tell that what will be the time required for conversion of 0.5 to 0.25 molar. Okay. So use the first condition where your initial concentration and a half life is given to find out the rate constant, and then put this value of rate constant in the second situation to find out the time required for the conversion of 0.5 to 0.25. Okay, so I am already seeing some answers. Option number C. Let us verify it. I will just wait for 1 more minute. You can just try it one more time if you want. Now you can see one more thing here before moving on to the solution, and it's a very important thing. What is that thing? It is given that you are starting from 2 mole per liter and you have to move on to a half life, and in that case your time is 1 hour. In the second situation, you are moving from 0.5 to 0.25. Here also you are finding the half life of the reaction, but it will change. It will have a different value, and that is for sure. Why? Because it is a zero order reaction. If it was the case for a first order reaction, then in that case you don't have to solve it at the first place. The same time will be applied for the second case also, but since it is a zero order reaction, you have to solve it, because for first order reaction your half life is independent of initial concentration. Okay, moving on to the solution. The correct answer will be C, 0.25 hour. Very good. So how we will solve it? First of all, we will write for a zero order reaction K is equals to A naught by 2 T half. Okay, A naught is the initial concentration, T half is the half-life. So what is given in the question? Initial concentration is given 2 mole per liter, and with respect to that, we also have the half-life value, which is 1 hour. If you put the values here, you will get your K as 1. Okay, very simple. Put A naught as 2, T half as 1. So that will simply give your K as 1. Now put this equation, put this value in the overall equation for the first order, which is A naught minus A by T. So T will be equals to 0.5 minus 0.25 by 1. Okay. So final concentration is given, initial concentration is given from the question, and you have already taken out the value of K. If you put it here, you will get the time required for this conversion. Next question. It is given that for a first order reaction, the time required for 99.9% of the reaction to take place is nearly 10 times that required for half of the reaction, 100 times that required for half of the reaction, 10 times that required for 1/4 of the reaction, and 20 times that required for the half of the reaction. So basically, you have to find the relation for time required for 99.9% completion and time required for half reaction or 1/4 of the reaction. So that will depend on the way you solve it. So let's just try to find it out. What will be the relation? So basically 99.9% means the amount of the amount of reactant which is consumed is 99.9%. Okay. That is the meaning of the given data. Again, I am repeating it. Time required for 99.9% completion means the 99.9% of your reactant is being converted to the product, or it is consumed. So your final concentration will be reduced to 0.1%. Okay. I guess it's very simple. What did I say? If 99.9% of the reactant is consumed, it means that 0.1% is left in the reaction mixture. So if you are getting the answer, please write it here. You have to define a relation between T 99.9% and T half. I will try to go slow because the student find it difficult to get if you are not getting the answer. But please try it by yourself and write the correct answer in the comment section. Okay, so this will be your last question. So if you are not getting it, no issue. Let me tell it for you because we are lagging time. So correct answer will be 10 times that required for half of the reaction. How I will solve it? As I said earlier, that the amount of reactant which is left is 0.1%. Okay. So we can write it that your rate law will be, for integrated rate law will be K is equals to 1 by T ln 100 by 0.1. So if you are taking 100 amount, then 0.1 is left. Okay, it is very simple, 100 minus 99.9. So think it in a different scale. So here you are not given the amount that you are taking, actual amount, but you are given in the percentage form. So we are assuming that we are taking 100 molar per molar solution. And according to the question, out of this 100, 99.9 is being consumed. Therefore, 0.1 will be left in the solution. Okay. So we always take this percentage, if it is given in the percentage form, we always take it in out of 100. That makes your solution easier. Now next, if you just solve it further, so this decimal will be pulled out and that will give you 1000 in the numerator. 1000 means 10 to the power 3. Here we also know one more thing. Since it is a first order reaction, therefore half-life is what? ln 2 by T half or 0.693 by T half. We have seen this in the theory part. So we have dragged that part and put it here in the place of K directly. Next, this T, remember this T that you are seeing, it is the time required for 99.9% completion, and this T half you are seeing is the time required for half-life. Next, what we can do, the value of log 10 to the power 3 can be written as 3. Simply it can be written as 3. Why? Because log a to the power x is x log a and log 10 has a value of 1. Okay. Similarly, here we have taken log 2. Basically, in place of ln, we have taken log on both sides by introducing 2.303 log, and this 2.303 will be cancelled on both sides, and therefore we are getting it as log 2 by t half is equals to 1 by 2 into log 10 to the power 3. This log 10 to the power 3 is written as 3, and this t remains in the denominator. Next, just solve this further. Bring this t half in the numerator part by cross multiplying it, and you will get it as t half is equals to log 2 by 3 into t. Again, this t is what? It is the time required for 99% completion. We have started with this only. So, what is log 2 by 3? It is 0.30103 by 3. We can approximate it. So, rather than taking this decimal part after the second digit, we will take it to first digit only, 0.3. So, 0.3 by 3 is simply 0.1. Okay, so it will be 0.1 t. Finally, we can tell that this t 99.9% is 10 times the t half if you just cross multiply this 0.1 on the left hand side. So, this is the overall solution of the given question. I hope this is clear to you. So, if you have a doubt, you can just post it here, or else we will move on to our math session in few minutes. Anyone who has a doubt in this part? Just see this solution, it's very simple. First, we have written it for the t 99.9%. Okay. Then, in place of k, we have replaced it with the half life, which is ln 2 by t half. We have seen this. T half is what? It is 0.693 by t half. Okay. Then we have equated it and tried to find the relation between t half and t, which is basically half life and 99.9% completion reaction. Okay, so this was all for today's class. I hope you enjoyed the session. Thank you for joining it.
Hello everyone, welcome to Crash Course. In today's lecture, we will cover, we will discuss some question based on indefinite integral. So at first we will summarize the concept of indefinite integral that we already discussed in last class. Then, then we practice question on indefinite integral. Okay, so integration of basic trigonometric and exponential integral. So like when we integrate sin x, we get minus cos x, and integration of cos x dx is sin x plus c. In the same way, we also read about formula for integration of tan x, cot x, sec x, cos x using logarithmic form. Now, for exponential, integration of e the power ax plus b is 1 by a e the power ax plus b plus c, and integration of ax dx is ax a the power x by ln a plus c. Now, to integrate integration of sin the power px cos the power qx, where p and q are rationals. So for this, if p is odd, then we substitute cos x st, and if q is odd, then we substitute sin x st. If both are odd, then we can substitute any of them as t. And if both are even, that means p and q both are even, then we use trigonometric identities to integrate sin the power px into cos the power qx. And for rational, and if p plus q minus 2 is negative integer, then we use substitution tan x is equal to t and cot x is equal to t. Okay. For integrate like integrand 1 by a plus b cos square x. So to integrate this, at first divide numerator and denominator by cos square x, and then rewrite the denominator by using the trigonometric entity, that is sec square x is equal to 1 tan square x, and then you substitute tan x is equal to t. And to integrate function like a sin x plus b cos x by c sin x plus d cos x dx is, we just express the numerator part, that is a sin x plus b cos x, as the linear combination of derivative of denominator and the denominator itself to simplify this integral. Okay. So how we write? We write a sin x plus b cos x is equal to a time differentiation of denominator, that is d by dx, c sin x plus d cos x plus b time c sin x plus d cos x, and where we can find the value of a and b by equating the coefficient of sin x and cos x, and then we can easily integrate this function. Okay. Now, to integrate we also use half angle substitution to integrate linear combination of denominator. Like if we have integral of the form like integral of 1 by a sin x plus b cos x, or integral of a plus b sin x, then what will we substitute sin x as 2 tan x by 2 by 1 plus tan square x by 2, and cos x as 1 minus tan square x by 2 by 1 plus tan square x by 2, and then put tan x by 2 as t. Okay. To integrate like function a sin x plus b cos x plus c by p sin x plus q cos x plus r dx, we express the numerator as we express a sin x plus b cos x plus c as a into differentiation of denominator part, that is d by dx, p sin x plus q cos x plus r plus b into p sin x plus q cos x plus r plus c. And then find the constant value of a and b by coefficient comparison. For rational function like integration of x square plus minus 1 by x to the power 4 plus k x square plus 1 dx, first divide the numerator and denominator by x square and then write the denominator as a perfect square of x plus minus 1 by x whole square, and then substitute either t is equal to x plus 1 by x or t is equal to x minus 1 by x as per requirement to integrate function like x square plus minus 1 by x to the power 4 plus kx square plus 1 dx. Now, to integrate irrational integrand like root under a minus x by a plus x, we use trigonometric substitution, and that substitution is x is equal to a cos 2 theta. For x by a plus x, we use substitution x equal to a tan square theta, and for function like root under x by a minus x, we use x equal to a sin square theta or a cos square theta. And if there is an integrand like root under x by x minus a, then we use x equal to a sec square theta. Okay, and if there is integrand like irrational integrand, that is root under x minus alpha beta minus x, then we use trigonometric substitution, that is x equal to alpha cos square theta plus beta sin square theta. Okay. Now, if there is a roots involving linear and quadratic terms, then we use substitution like ax plus b is equal to t square, px plus q is equal to 1 by t. Okay. Now, there is an important formula in integration, that is by parts formula, that is used to integrate product of two function. If there is two function u and v and we want to integrate its product, that is integration of u into v dx, then we integrate by parts, and that formula is u into integration of v dx minus integration of du by dx by integration of v dx dx. And in by parts formula, we have to choose u and v, which function we want to choosing as u, the first function, and which function we want to take it as v, that is second function, and we choose by this order inverse. It's represent the integration of inverse function is comparatively difficult than other function, and as exponential come in the last, so integration of exponential function is easier comparing to other function. So we choose u based on this order. Okay. Some standard formula, that is integral of ex fx plus f dash x is equal to fx ex plus c, and we also discuss in the last class, that is integration of e to the power ax sin bx plus c, and for the integration of ex cos bx plus c, we get its formula by parts. Now, other method of integration is partial fraction decomposition. If your given integral is of the form integration of px by qx dx, where the degree p is less than q, then px by qx is given by, we just write in the form of partial fraction, like we write in the based on the fraction nature of qx, if it is written in the product of linear factor, then we write a1 by x minus a1 plus a2 by x minus a2 plus a3 by x minus a3, where this is a linear factors of qx, where this ai can be found by equating coefficient, and then we can integrate. Okay. Okay. So now we solve some question. So the question number 7, integrate x square by x sin x plus cos x whole square dx. Given options are a sin x plus cos x by x sin x plus cos x plus c. Option B, x sin x minus cos x by x sin x plus cos x plus c. And option C, sin x minus x cos x by x sin x plus cos x plus c. And D, none of the above. Okay. So let's solve this. Correct answer is sin x minus x cos x by x sin x plus cos x plus c. Okay. So let I is equal to integral of x square by x sin x plus cos x whole square dx. We want to integrate this function. So to integrate, what we do? We multiply the numerator by cos x and cos x by denominator. So we just decompose x square as x into x. So we get x cos x into x by x sin x plus cos x whole square cos x. Okay. Now we want to integrate this. So we use the by parts method to integrate this. Consider first function as u and second function as v. So we have to integrate this function x cos x by x sin x plus cos x whole square. What is the formula for by parts? That is integration of ub dx is equal to u into integration of v dx minus integration of du by dx integration of v dx dx. Okay. So we consider x cos x, x sin x plus cos x as v and x by cos x as u. So we need to integrate this first term, that is x cos x by x sin x plus cos x whole square. So for that, what we do? We substitute this numerator as new variable, that is x cos x plus cos x as, let's take it as t. And when we differentiate this with respect to x, we get x cos x. Okay. So x cos x dx is equal to dt. So we get integration of dt by t square, and for that integration is minus 1 by t and t is x sin x plus cos x. So we get minus 1 by x sin x plus cos x. This is the integration of x cos x by x sin x plus cos x whole square. Clear? Into v into u. So that is a formula is u into integration of v dx. So integration of v dx into u, that is x cos x plus integration of, now we differentiate this x by cos x. Now differentiation for u by v, if there is a function u by v and we want to differentiate this, then the formula is v into du minus u into dv by v square. So differentiation of x by cos x is cos x into differentiation of x, that is 1 minus x into differentiation of cos x, that is minus sin x by cos square x. And integration of x cos x by x sin x plus cos x whole square is minus 1 by x sin x plus cos x. So we get plus integration of 1 by x sin x plus cos x. Okay. So from here we get minus x by x sin x plus cos x into cos x and plus 10x plus c, as because in the second term x sin x plus cos x cancel out from the numerator and denominator, we get 1 by cos square x dx, that is sec square x dx, and integration of sec square x dx is 10x. So we get minus x by x sin x plus cos x into cos x plus 10x plus c. And when we write 10x as sin x by cos x and simplify it, we get minus x plus x sin square x plus sin x into cos x by x sin x plus cos x into cos x plus c. Clear? So just simplify it. What we do? Just take x as common from first two term. So we get minus 1 plus sin square x, take minus as common, so we get 1 minus sin square x, that is become cos square x. When you take cos x as common, cos cancel out, we left with sin x minus x cos x by x sin x plus cos x plus c. So correct option is option C for the integral of x square by x sin x plus cos x whole square dx. So just use the trick, we multiply and divide the integrand by cos x, and then we apply by parts method and then simplify, just use the calculation to solve this integral. Okay. Now, question number 8. If fx is equal to integral of x square dx by 1 plus x square into 1 plus root under 1 plus x square. Okay. And another information is f0 is equal to 0. Okay. That means if you integrate it, we get a function that is your fx. And when we take 0 for f, so f0 is equal to 0, then we have to find the value of f at 1. And options are log 1 plus root 2, log 1 plus root 2 minus pi by 4, C log 1 plus root 2 plus pi by 2, and D none of this. Okay. So to integrate this, we need an appropriate substitution so that it transform to an easily convertible. It convert to in the form where we can easily integrate that. Okay. So correct option is option B, that is log 1 plus root 2 minus pi by 4. So let's solve. So fx is equal to integration of x square dx by 1 plus x square into 1 plus root under 1 plus x square. So how we integrate this? We take x is equal to tan theta as our substitution. So when we take x is equal to tan theta and we differentiate it, we get dx is equal to sec square theta d theta, differentiation of tan x with respect to x. So we get, when we differentiate x with respect to dx, we get dx is equal to sec square theta d theta, and we know that sec square theta is 1 plus tan square theta. So it can be written as tan theta is equal to x. So we can write it as 1 plus x square d theta. Okay. So we get fx is equal to integral of tan square theta sec square theta d theta. We replace x square by tan square theta, and in place of dx we write sec square theta d theta. For 1 plus x square we write sec square theta, and then we get 1 plus root under 1 plus tan square theta. 1 plus tan square theta become sec square theta, and root under sec square theta becomes sec theta. So we get in the denominator part sec square theta into 1 plus sec theta. Okay. Now sec square theta is cancelled out from the numerator and denominator. We get tan square theta by 1 plus sec theta. Now write tan square theta as sin square theta by cos square theta, and write sec theta as 1 plus 1 by cos theta. And when you simplify, we write sin square theta as 1 minus cos square theta, and by cos theta into 1 plus cos theta. Just simplify the denominator part, that is 1 plus 1 by cos theta. So we get cos theta plus 1 by cos theta. Cos square theta is cancelled out. We only get cos theta. So we get integral of 1 minus cos square theta by cos theta into 1 plus cos theta d theta. Okay. Now write this 1 minus cos square theta as 1 minus cos theta into 1 plus cos theta. A square minus b square is equal to a minus b into a plus b. So we get 1 minus cos theta into 1 plus cos theta. 1 plus cos theta is cancelled out. We get 1 minus cos theta by cos theta. So when we separate, we get 1 minus cos theta, that is sec theta, and cos theta by cos theta, that is theta. So we get integration of sec theta d theta minus integration of d theta. And integration of sec theta is log sec theta plus tan theta minus integration of d theta is theta. So you get minus theta plus c. Now substitute back, write the term with x. So as x is equal to tan theta, so we write log, in place of tan theta we write x, and for sec theta we can write root under 1 plus x square. Okay. And for theta we can write tan inverse x. So minus tan inverse x plus c. Now it is given that f0 is equal to 0. So when we substitute 0 in place of x, we get f0 is equal to log 0 plus root under 1 plus 0 minus tan inverse 0 plus c. So as we know, log 1 is 0 and tan inverse 0 is 0. So you get c is equal to 0. So just substitute into the value of fx. We get fx is equal to log x plus root under 1 plus x square minus tan inverse x. So the value of f1, substitute x is equal to 1 in the value of fx, we get log 1 plus root 2 minus tan inverse 1, that is pi by 4 plus 0. So the value of f1 is log 1 plus root 2 minus pi by 4. Okay. So that is the value of f1. So to integrate this integrand, we just take a substitution, x is equal to tan theta. Okay. And then simplify. Clear? Now question number 9. Given I is equal to integral of dx by root cube x plus 1 whole square x minus 1 the power 4 is equal to k into root cube root 1 plus x by 1 minus x plus c. Then k is equal to, options are 2 by 3, 3 by 2, 1 by 3, 1 by 2. So in this question we have to solve this integral, that is I is equal to dx by cube root x plus 1 whole square x minus 1 the power 4, and it must be in the form of this k into root cube root under 1 plus x minus 1 minus x plus c. Then we can compare and find the value of k. Okay, so let's solve. So how to solve this? Correct answer is option B, that is 3 by 2. So I is equal to integral of dx by cube root x plus 1 whole square x minus 1 whole power 4. Okay, so what we do, we just take a common 1 minus x the power 6. We can write x minus 1 the power 4 as 1 minus x the power 4. Okay, and when we take 1 minus x the power 6 common from this cube root, we get 1 minus 6 the power 6 into 1 by 3, that is 2. So we get dx by 1 minus x whole square cube root x plus 1 by x minus 1 whole square. Okay, we just take 1 minus x the power 6 common from this cube root. So 1 minus x the power 2 come out from this cube root. Okay, now as a substitution we take x plus 1 by 1 minus x as new variable t. So we just apply this substitution to simplify this integral. Clear? Now we differentiate this with respect to x. We get 2 by 1 minus x whole square dx is equal to dt. That is integration of differentiation of u by v is b into differentiation of u v du minus u into dv by v square. So just use that formula. We get 2 by 1 minus x whole square dx is equal to dt. Okay, so we get I is equal to, replace 2 by 1 minus x whole square dx is equal to dt. So for that we substitute dx by 1 minus x whole square as dt by 2. So we get 1 by 2, and we know that we substitute 1 plus x 1 by 1 minus x as t. So from here we get t the power 2 by 3, and there is a cube root, and so we get cube root is 1 by 3, power 1 by 3. So we get t the power 2 by 3. That is equal to, when we integrate t the power 2 by 3, we get 3 by 2 into t the power 1 by 3 plus c. Now substitute back the value of t, that is 1 plus x by 1 minus x. So we get 3 by 2 cube root 1 plus x by 1 minus x plus c. And when we compare this with k into cube root 1 plus x by 1 minus x plus c, we get the value q as 3 by 2. Clear? So here the main thing is we take common 1 minus x the power 6 from this cube root, and we take 1 plus x by 1 minus x as new variable t. Question number 10. So here in this question we need to integrate dx by sin x plus 2 into sin x minus 1 is equal to, option A is 2 by 3 tan x by 2 minus 1, minus 2 by 3 root 3 tan inverse 2 10 x by 2 plus 1 by 2 by root 3 plus c. Option B 2 by 10 x by 2 plus 1 plus c. Option C minus 2 by 3 into 1 by 10 x by 2 minus 1 plus 2 by 3 root 3 tan inverse 210 x by 2 minus 1 by root 3 plus c. And option D minus 2 by 3 2 by 10 x by 2 minus 1 plus 2 by 3 root 3 tan inverse 210 x by 2 minus 1 by root 3 plus c. So these are the option. So we need to integrate this, that is dx by sin x plus 2 sin x minus 1. Okay, so how integrate this? Correct answer is option A, that is 2 by 3 10 x by 2 minus 1 minus 2 by 3 root 3 tan inverse 2 10 x by 2 plus 1 by 2 by root 3 plus c. Okay, so let's solve. So integral of dx by sin x plus 2 sin x minus 1. Okay, so we can write the numerator part as sin x plus 2 minus sin x minus 1 by 3, because sin cancel out, we get 2 minus minus 1, that is 2 plus 1, that is 3. So when we divide the numerator, we get exactly the 1. So we can write the numerator as sin x plus 2, that is we can write 1 as sin x plus 2 minus sin x minus 1 by 3. So we get 1 by 3 integral of dx by sin x minus 1. Sin x plus 2 is cancelled out, we get dx by sin x minus 1 minus 1 by 3 dx by sin x plus 2. Now we can easily integrate this. And for that, we know the formula of sin x in terms of half angle of 10. We can write 2 10 x by 2 by 1 plus 10 square x by 2. This is the formula for sin x. Minus 1. Also replace for the second term, that is minus 1 by 3 dx by sin x is equal to 2 10 x by 2 by 1 plus 10 square x by 2. Why use this identity? For a substitution, and that substitution is just substitute 10 x by 2 as new variable t. So we get 10 x by 2 is equal to t. Now differentiate this. We get differentiation of 10x is sec square, as the half angle we apply the chain rule, and the differentiation of x by 2 is 1 by 2. So we get 1 by 2 sec square x by 2 dx is equal to dt. So we get I is equal to 1 by 3, and we can substitute 1 by 2 sec square x by 2 dx as dt. So when we simplify the above one, 1 plus 10 square x by 2 is come in the numerator part, and it becomes sec square. We know that 1 plus 10 square x by 2 is sec square x by 2. So we can write sec square x by 2 dx as 2 dt. So we get 1 by 3 integral of 2 dt by, for 10x by 2 substitute t. So we get 2t minus 1 into 1 plus 10 square x by 2. So when you replace 10 square x by 2 by t, we get 2t minus 1 minus t square. Clear? Minus 1 by 3 2 dt. In a similar way, by, for 2 10x by 2 we replace t, so 2t plus 2 into 1 plus 10 square x by 2. So we get 2 into t square plus 1, that is 2 into t square plus 2. Now just take minus common for the first term. So you get minus 2 by 3 integral of dt by t minus 1 whole square, because when we take minuses common, we get t square minus 2t plus 1, and that is the formula of t minus 1 whole square. So you get minus 2 by 3 integral of dt by t minus 1 whole square minus 1 by 3 integration of dt by, when you take 2s common, so also from the denominator part 2 is we can take 2s common, so 2 cancel out, we get integration of dt by. Now by using the complete square method, we can write this as t plus 1 by 2 whole square plus root 3 by 2 whole square. Now we can easily integrate both this term. Okay, for the first term, the integral is 2 by 3 into 1 by t minus 1. We just apply the algebraic rule, the power rule, minus 1 by 3 into 2 by root 3 tan inverse, that is a special form, So we just apply the formula for special form, that is, so we get 2 by root 3 tan inverse t plus 1 by 2 by root 3 by 2 plus c, and that is equal to, now substitute back the value of t, that is 10x by 2, so we get 2 by 3 into 10x by 2 minus 1 minus 2 by 3 root 3 tan inverse 2 10x by 2 plus 1 by 2 by root 3 plus c. Okay, clear? Next question, we have to integrate x square by 2 plus 3x square whole power 5 by 2. This is your integrand. And options are, first option A, 1 by 5 x square by 2 plus 3x square whole power 3 by 2 plus c. Option B, 1 by 6 into x square by 2 plus 3x square whole power 3 by 2 plus c. And option C, 1 by 6 into x square by 2 plus 3x square whole power 7 by 2 plus c. And option D, none of the above. Okay, so let's solve. Correct answer is option B, that is 1 by 6 x square by 2 plus 3x square whole power 3 by 2 plus c. Consider it as I, so I is equal to integral of x square by 2 plus 3x square whole power 5 by 2 dx. So here, as a substitution, it is a unique substitution, we take 2 plus 3x square as t square x square. Okay, that's your substitution for this integrand. So from here we get x square is equal to 2 by t square minus 3. How we get this? Just take 3x square on the right hand side, we get 2 is equal to t square x square minus 3x square. When we take x square as common, we get t square minus 3, and so x square is equal to 2 by t square minus 3. And when we differentiate this with respect to x, we get 2x dx is equal to 2 as constant, and when we differentiate 1 by t square minus 3, we get minus 2t by t square minus 3 whole square dt. Okay, so we get dx is equal to minus 2t, 2 to cancel out, from the left hand side and right hand side we get dx is equal to minus 2t by x into t square minus 3 whole square dt. That is, now we can write I as integral of x square by, in place of t plus 3x square power 5 by 2, as we know, we substitute 2 plus 3x square as t square x square, that is tx whole square. So we get tx whole square into 5 by 2, 2 to cancel out, we get tx to the power 5 into, for dx we substitute minus 2t by x into t square minus 3 whole square dt. Okay, now in place of t square minus 3 whole square, we can write 2 by x square, that is 2 by x square whole square. And when we simplify this equation, x term is totally cancelled out, we only left with minus 2 integral of dt by 4 into t to the power 4, that is minus 1 by 2 integral of dt by t to the power 4. And when we integrate this, we get 1 by 6 into t cube plus c. Okay, now substitute back the value for t, we get 1 by 6 x square by t plus 3x square power 3 by 2 plus c. Okay, question number 12, we have to integrate integral of 1 plus x minus 1 by x into e the power x plus 1 by x dx is equal to, options are x minus 1 into e the power x plus 1 by x plus c, option B, x into e the power x plus 1 by x plus c, option C, x plus 1 e the power x plus 1 by x plus c, and D, minus x e the power x plus 1 by x plus c. Okay, so try to solve this. Here, just at first split the integral in two terms, and then we need to apply the by parts to solve this. Okay, so try. Okay, let's solve. Answer is option B, that is x into e the power x plus 1 by x plus c. How we get this? So consider it as I. So I is equal to integral of 1 plus x minus 1 by x into e the power x plus 1 by x dx. So we can split it into two terms. So when we distribute this integral, we get 1 into e the power x plus x dx. So we get e the power x plus 1 by x dx plus integral of x into 1 minus x square e the power x plus 1 by x dx. Okay, we just take x common from x minus 1 by x. So we get x into 1 minus 1 by x square e the into e x plus 1 by x dx. Now we apply by parts on the second term. So we get integration of e the power x plus 1 by x dx, the first term. And when we apply by parts in the second term, we know that integration of 1 minus x square 1 minus 1 by x square e the power x plus 1 by x dx is equal to e the power x plus 1 by x. We can easily get this by just taking substitution as x plus 1 by x as new variable t. And when you apply the whole substitution method and integrate this, we get e the power x plus 1 by x. So we consider this as v, and when we apply the by parts formula, we get x into e the power x plus 1 by x, that is x into integration of 1 minus x square 1 by x square e the power x plus x minus differentiation of function u, that is dx by dx into e the power x plus 1 by x, that is integration of second function dx. That is integration of e the power x plus 1 by x dx plus x into e the power x plus 1 by x minus differentiation of dx is dx 1, so we get minus integration of e the power x plus 1 by x dx. Now first and last term is one with positive, one with negative, so it cancel out. We get x into e the power x plus 1 by x plus c, that is constant of integration. So correct answer is option B, that is x into e the power x plus 1 by x plus c. Okay, just wait for a moment. Okay, so next question is the integral 2x power 12 plus 5 into x the power 9 by x the power 5 plus x cube plus 1 whole power cube dx is equal to, options are A minus x the power 5 by x the power 5 plus x cube plus 1 whole square plus c. Option B, x to the power 10 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. And option C, x to the power 5 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. And option D, minus x to the power 10 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. So we need to integrate this integrand. And integrand is 2x is 2 into x to the power 12 plus 5 into x to the power 9 by x to the power 5 plus x to the power 3 plus 1 whole cube. Okay. So we just need an appropriate substitution so that we can easily integrate this integrand. Okay. Correct answer is option B, that is x to the power 10 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. So let's solve. Consider it as I. So I is equal to integral of 2 into x to the power 12 plus 5 into x to the power 9 by x to the power 5 plus x cube plus 1 whole cube dx. So just take x to the power 5 as common from this cube power. So when you take x to the power 5 common, we get x to the power 5 whole power 3, that is x to the power 15. So we get as x to the power 15 common from this bracket, that is we get 1 plus x to the power minus 2 plus x to the power minus 5 inside the bracket. When we take x to the power 5 as common and from this bracket, that it become x to the power 15 when it come out from this power cube. So we get integral of 2x to the power 12 plus 5x to the power 9 by x to the power 15 into 1 plus x to the power minus 2 plus x to the power minus 5 whole cube dx. Okay. Now, when we divide the numerator part by x to the power 15, we get 2 into x to the power 12 by x to the power 15. It becomes 2 into x to the power minus 3 plus 5 into x to the power 9 by x to the power 15. We get 5 into x to the power minus 6 by 1 plus x to the power minus 2 plus x to the power minus 5 whole cube dx. Okay. Now, we just put 1 plus x to the power minus 2 plus x to the power minus 5 as a new variable t. Okay. And when we do this, so we know how we apply the substitution method to solve an integral. Now differentiate this with respect to x. We get differentiation of 1 is 0 and differentiation of x to the power minus 2 is minus 2 into x to the power minus 3 minus 5 x to the power minus 6, because differentiation of x to the power minus 5 is minus 5 x to the power minus 6 dx is equal to dt. That is equal to 2 into x to the power minus 3 plus 5 into x to the power minus 6 dx. We just take minus as common and is equal to minus dt. So if you observe, this term is exactly the term that is in the numerator part of integrand. So now we can replace it with minus dt. So you get I is equal to minus integral of dt by t cube. As we replace 1 plus x minus 2 plus x to the power minus 5 as t. So in the denominator we get t cube, that is equal to minus integral of t to the power minus 3 dt. Okay. And the integration of t to the power minus 3 is t to the power minus 3 plus 1 by minus 3 plus 1 plus c. That is equal to 1 by 2 into t square plus c. Now we substitute back the value of t. So when we substitute back and when we simplify it, we get x to the power 10 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. Okay. So in this question, to solve this, at first we take x to the power 5 common from this denominator part, that is become x to the power 15 as it is cube power. So you get x to the power 15. Then we divide the numerator part with x to the power 15, and after the division we substitute the denominator part of integrand as a new variable t, and when we differentiate that, we get the numerator part of the numerator. Okay, that is numerator minus of numerator part, that is 2x to the power minus q plus 5 into x to the power minus 6 dx as minus dt. So we just use this substitution and get the solution as x to the power 10 by 2 into x to the power 5 plus x cube plus 1 whole square plus c. Next question, integrate x square minus 1 by x cube into integration of 2 into x to the power 4 minus 2x square plus 1 dx is equal to, options are option A root under 2 into x to the power 4 minus 2x square plus 1 by x square plus c, option B root under 2 into x to the power 4 minus 2x square plus 1 by x plus c, and option C root under 2 into x to the power 4 minus 2x square plus 1 by 2x plus c, option D root under 2 into x to the power 4 minus 2x square plus 1 by 2x square plus c. Okay, so try to solve this problem. As a first step, you can take x to the power 4 common from this root square root, that become x square, so it become x to the power 5. So take this as a first step, as a hint, and then try to solve. Choose appropriate substitution. Substitution method is very powerful method to solve such kind of integrand, to find such kind of integral. Okay, so correct answer is option D, that is root under 2 into x to the power 4 minus 2x square plus 1 by 2x square plus c. So let's solve. Consider it as function I, that is I is equal to integral of x square minus 1 by x cube root under 2 into x to the power 4 minus 2x square plus 1 dx. So when we take x square common, x to the power 4 common under this square root, so it come out from the square root and it become x square. So that become x square minus 1 x cube into x square under root 2. We take x to the power 4 as common, so 2 minus 2 by x square plus 1 by x to the power 4. When you take x to the power 4 common from 2 into x to the power 4 minus 2x square plus 1, we get this 2 minus 2 to the power 2 by x square plus 1 by x to the power 4. So after that, just divide the numerator part by x to the power 5. So when we divide x square by x to the power 5, we get 1 by x cube minus 1 by x to the power 5. And in the denominator part, that is root under 2 minus 2 by x square plus 1 by x to the power 4 dx. After that, we substitute this under root expression, that is 2 minus 2x square plus 1 by x to the power 4 as t, as a new variable t. Now differentiate this. So when we differentiate this, we get 4 into 1 by x cube minus 1 by x to the power 5 dx is equal to dt. And this is exactly the constant multiple of the numerator part. So we can write 1 by x cube minus 1 by x to the power 5 dx as dt by 4. So I is equal to 1 by 4 dt by root under t, because t is equal to 2 minus 2 by x square plus 1 by x to the power 4. Okay. Now we can easily integrate this, that is integration of dt by root 2. So integration of dt by root 2 is 2 root 2. So 1 by 4 into 2 root 2 plus c. Now substitute back the value of t. We get root under 2 into x to the power 4 minus 2x square plus 1 by 2x square plus c. Substitute back the value of t as 2 minus 2 by x square plus 1 by x to the power 4, and we simplify it. Then we get root under 2 into x to the power 4 minus 2 into x square plus 1 by 2x square plus c. Okay. So question number 15 is, we have to integrate dx by 1 plus x square root under p square plus q square tan inverse x whole square. And so there are some options. So correct answer is option A, that is 1 by q log q tan inverse x plus root under p square plus q square tan inverse x whole square plus c. So let's solve it. To integrate this integrand, we take substitution as q tan inverse x is equal to t. And when we take q tan inverse x is equal to t, and when we differentiate it, what we get? Q by 1 plus x square dx is equal to dt. Okay. So now 1 plus x square dx is equal to dt by q. So in the integrand, the term dx by 1 plus x square now can be replaced by dt by q. So my I become, if we take the integral as I, so my I become dt by dx by 1 plus x square is replaced by dt by q. So it become integral of dt by q root under p square plus q square tan inverse x whole square. And we substitute q tan inverse x as t. So we get dt by q root under p square plus t square. Okay. And this is your special case. We know the formula for this. And that is equal to 1 by q log mod t plus root under p square plus t square. Now substitute back the value of t. So we get 1 by q log q tan inverse x plus root under p square plus q square tan inverse x whole square plus c. This is your correct answer. Now question number 16. In the integration of cos 8x plus 1 by cot 2x minus tan 2x dx is equal to a cos 8x plus k, where k is an arbitrary constant, then what is the value of a? Options are minus 1 by 16, option B 1 by 16, option C 1 by 8, and option D minus 1 by 8. Okay. So to solve this, we use trigonometric identities. So what is cos 8x plus 1? Okay. So just recall the different trigonometric entities and try to solve this problem. At first, replace cot x by cot 2x by cos 2x by sin 2x and tan 2x as sin 2x by cos 2x. Okay. Then try to solve. Okay, so let's solve. Correct answer is option A, that is minus 1 by 16. So let's verify it. So just take LHS part, that is integration of cos 8x plus 1 by cot 2x minus 10 2x. So we can write this cos 8x plus 1 as 2 cos square 4x. Okay, as we know that cos 2x plus 1 is 2 cos square 2x. Okay, so by using the trigonometric identity of cos 2x plus 1, that is equal to 2 cos square x, we get 2 cos square 4x for 8x. Okay, by when we replace cot 2x by cos 2x by sin 2x and this 10 2x by sin 2x by cos 2x, and we subtract them, we get cos square 2x minus sin square 2x by cos 2x into sin 2x dx. Okay, now this term cos 2x sin 2x, it come to the numerator part, we get 2 cos square 4x into sin 2x cos 2x by cos 4x dx, by using the formula of cos square 2x minus sin square 2x, that is become cos 4x. Okay, because we know that cos square x minus sin square x is equal to cos 2x. Okay, now we know that 2 sin x into cos x is sin 2x, so we use this trigonometric entity for cos 2x sin 2x, that is 2 cos 2x sin 2x is equal to sin 4x. So we get, and cos x cos 4x is cancelled out from the numerator part, we get single cos 4x into sin 4x dx. Now we again use the same trigonometric entity, that 2 sin x cos x is sin 2x. So we just multiply and divide by 2. So when we multiply, divide by 2, that is 2 into cos 4x plus sin 4x by 2, we get sin 8x by 2. That is integration of sin 8x by 2. 1 by 2 is constant term, so it come out. So we get 1 by 2 integration of sin 8x dx. So now we can easily integrate this. We know that integration of sin x is minus cos x. So we use the substitution method, we take 8x as new variable, and when we apply the substitution method, we get minus 1 by 2 cos 8x by 8 plus k. Okay, so when we compare this with RHS part, the value of a is minus 1 by 2 into 8, that is minus 1 by 16. Clear? Okay, question number 17. Integrate sin theta plus cos theta by root under sin 2 theta d theta. Options are log mod cos theta minus sin theta plus root under sin 2 theta. Option B, log mod sin theta minus cos theta plus root under sin 2 theta. Option C, sin inverse sin theta minus cos theta plus C. And option D, sin inverse sin theta plus cos theta plus C. Okay. So to solve this problem, we use trigonometric entities always as substitution. Okay. So just think how we can solve this. So let's solve. Correct answer is option C, that is sin inverse sin theta minus cos theta plus C. So consider it as I. So I is equal to integral of sin theta plus cos theta by root under 1 minus 2 sin theta cos theta d theta. So we just add 1 and subtract 1 in the denominator part under this square root. Now we can write this one as sine square theta plus cos square theta, because we know that sine square theta plus cos square theta is equal to 1. So when we write this one as sine square theta plus cos square theta, we get sine square theta plus cos square theta minus 2 sin theta and cos theta. That is a formula for sine theta minus cos theta whole square. So get integral of sine theta plus cos theta under root 1 minus sine theta minus cos theta whole square d theta. Now we take sine theta minus cos theta as your substitution as new variable t, and when we differentiate this, we get cos theta plus sine theta d theta is equal to dt. Okay, so I is equal to integration of dt by root under 1 minus t square. Okay, as cos theta plus sine theta d theta is equal to dt, so we replace sine theta plus cos theta d theta by dt and under root 1 minus t square. And this is a special type of integral, and we know this integral of this is sine inverse t plus c. So substitute back the value of t, so we get sine inverse sine theta minus cos theta plus c. Okay, question number 18. Integrate fx into g dash x minus f dash x into gx by fx into gx into log gx minus log fx dx is equal to, options are log gx by fx plus c, option B 1 by 2 gx by fx whole square, option C 1 by 2 log gx by fx whole square plus c, and option D log gx by fx square plus c. Okay, so let's solve. Correct answer is option C, that is 1 by 2 log gx by fx whole square plus c. So let I is equal to integral of fx into g dash x minus f dash x into gx by fx into gx into log gx minus fx become log gx by fx dx. So we take gx by fx as a variable t, because when we differentiate it, we know the rule of differentiation for gx by fx, that is fx into g dash x minus gx into f dash x by fx whole square dx is equal to dt. Now we can manipulate this. So when we multiply and divide by gx, we get fx into g dash x minus gx into f dash x by fx into gx. And this is exactly this term available on your integrand into gx by fx into dx is equal to dt. So we can write fx into g dash x by gx into f dash x by fx into gx by dx is equal to dt by t, where t is gx by fx. So just use this substitution, we get I is equal to integration of 1 by t into log t dt. Okay, now you have to integrate this, that is 1 by t log t dt. So to integrate this, we just take log t as new variable z. So when we take log t as new variable and we differentiate that, we get 1 by t as a differentiation. So when we use that substitution as log t as new variable, we get log t whole square by 2 plus c as its integral. Okay, so substitute back the value of t, so we get 1 by 2 log gx by fx whole square plus c, that is the integral of integration fx dot g dash x minus f dash x into gx by fx into gx into log gx minus log fx dx. Okay, we just observe this integrand in this question. We just observe the integrand, and by this seeing this integrand, we choose an appropriate substitution gx by fx equal to t, because we know that when we differentiate this, we get fx into g dash x minus gx into f dash x by fx into gx dx as dt by t. Okay, so in today's lecture, we practice some question based on indefinite integral. I hope this lesson was helpful. Any doubt? Okay then. Thank you. Hello everyone. In today's lecture, we are going to learn about oscillations. Alright, and this is theory part. This is our disclaimer. If we talk about the trend analysis in JEE Main exams, according to last 5 years, so we can say overall weightage is 2.9% of this chapter, oscillations. Alright, if we talk about yearly quotient distribution, so we can say in 2024 question asked from simple harmonic motion. Number of questions 1, and if we talk about their difficulty level, so we can say question was average. In 2023 question asked from energy in simple harmonic motion. Number of questions 2, and both question was average. Okay. In 2022 question asked from again from simple harmonic motion. Number of questions 1, and their difficulty level average. Okay. In 2021 question asked from some systems executing simple harmonic motion. Number of questions 1, and their difficulty level average. Okay. And we can say these topics are very important for the exam. All right everyone. So in today's lecture we will cover first periodic motion, then simple harmonic motion. After that we will discuss terms related to simple harmonic motion. Okay. Then we will see oscillations of a spring. After that we will learn series combination of springs. You know, combination of springs, series combination and parallel combination. Then we will discuss parallel combination of springs. Then we will talk about force and energy in simple harmonic motion. Then composition of 2 SHM. All right. Then and last we will discuss about simple pendulum. Okay everyone. So let's start with periodic motion. Okay. The important point here is this: in this in this topic, we will provide a quick revision for you here. Okay. Therefore, I am proceeding accordingly. I will not explain how the derivation came out. Okay. So the concept is periodic motion. If we talk about the definition, so we can say uh, periodic motion, uh, a motion which repeats itself over a regular interval of time, is called a periodic motion. Motion which repeats itself after a regular interval of time. In other words, any motion that repeats itself after a regular interval is termed periodic motion. Okay. Any periodic motion in which a body moves back and forth repeatedly about a fixed point is called oscillatory or vibratory motion. That is, if a body oscillates about a point, uh, it is called oscillatory motion. Or even if it simply exhibits back and forth motion, it is referred to as oscillatory or vibratory motion. Okay. Next term is period. the regular time interval after which periodic motion repeats itself is called the period of the motion. In other words, uh, it is the time interval after which the entire periodic motion repeats itself. Okay, for instance, if a particle starts from a point, completes a full rotation, okay, and returns to the same point, so the time taken for this complete rotation is called the period. Okay, thus the time taken for one complete rotation is defined as the period. Next is frequency. The number of times the motion repeats in 1 second, or how many repetitions occur per second is called frequency. For example, uh, if it completed 2 rotations in 1 second, okay, then the frequency will be 2 hertz. All right, or we can say if it completed 10 rounds in 1 second, then the frequency will be 10 hertz. So the number of times the motion repeats in 1 second is called the frequency of the periodic motion. Here hertz is the unit of the frequency. Okay, now the important point here is that every oscillatory motion is periodic, but not every periodic motion is oscillatory. It is important to note here that while every oscillatory motion is periodic, not all periodic motions are oscillatory. This means a periodic motion could involve moving from one point to another, then to a third, returning to the first, and then repeating the same path. Okay, next is displacement as a function of time. In periodic motion, after every regular interval, that is a particular time period, the displacement values repeats itself. So displacement can be represented in the form of a function of time as a y equal to f of t. All right, next is periodic function. So now let's talk about a periodic function. This function repeats its value after a fixed interval, which we can mathematically represent as y of t equal to y of t plus capital T. Now we talk about trigonometry functions like sine theta, cos theta. Okay, so we can say sine theta and cos theta, or we can say trigonometry functions are the most common periodic functions whose period is 2 pi. Okay, so here our main aim is to understand the periodic motion, a motion which repeats itself over a regular interval of time. Okay, everyone. Next is simple harmonic motion. Now let's proceed and study simple harmonic motion. So simple harmonic motion is a type of oscillatory motion. You see what we studied so far is that there are periodic motions. Many of them periodic motions are of various types. Among them, one is oscillatory motion, and oscillatory motions are also of several kinds. Among them, there is a special type which is called simple harmonic motion. Okay, and in this simple harmonic motion, the condition is that
the general condition for oscillation will still apply. So it means we can say the particle will move to and fro or back and forth under a restoring force. Okay, but here a very important condition is that the force is directly proportional to x. That is, if we write it, then F equal to minus kx. Okay, here the term we can say like force is directly proportional to x. So for removing the directly proportionality sign, there is a constant, that is k here. And this is our complete equation for simple harmonic motion, which indicates that the applied force in the opposite direction to the displacement. Okay, here minus sign shows the up direction. So we can say a type of restoring force. It means a type of restoring force. If the particle is moving in this direction, okay, suppose forward direction, all right, so then the force will act in the opposite direction. It means backward direction. And if the particle moves to other side, then the force will be in the opposite direction. It means force will always pull the particle towards a point. It will not let it go further. It will always pull it back. All right, where k is a positive constant called the force constant or spring factor, and x is displacement. Differential equations of simple harmonic motion for linear SHM. We will modify this concept here. So we can write it using mass m and minus kx, restoring force. Okay, so if we divided by m, we call ky m omega square. Thus the equation will be d square y upon dt square plus omega square y equal to 0. And if in this equation you replace y, replace x with y, suppose that the motion in the y direction, or we can suppose the motion in the x direction, then it will become d square x upon dt square plus uh, omega square x equal to 0. And if it is happening at an angle theta, then it will become d square theta upon dt square plus omega square theta equal to 0. This is the equation for simple harmonic motion. Alright, and so for linear simple harmonic motion, this is the equation whether you you use x or y or z. The same equation will appear in all cases. And if it is angular SHM, then theta will appear here. Okay, theta here is the angle. You can also represent the angle with phi or any other symbol, but here it will be an angle. So d square theta upon dt square plus omega square theta equal to 0. This is the equation for SHM, simple harmonic motion. And the condition mentioned here, that a very important condition is very important. So a equal to minus omega square x. This is very useful. Okay, so there are some important terms related to SHM such as displacement. So displacement, all right. Okay. So here we will learn how we can write the equation for a displacement of a particle executing SHM. So when SHM is occurring, the displacement of a particle can be expressed as a y equal to a sine omega t minus phi. Okay, where a is the amplitude of SHM and omega is the angular frequency. The value of omega is 2 pi by capital T, that is omega equal to 2 pi nu. Okay. So these are the equations to find out the omega. Omega equal to 2 pi upon T, or we can say omega equal to 2 pi nu. Nu is the frequency. All these things that I am marking, all these are important. Okay. And now the phi is the initial phase of SHM. Displacement can be expressed in another way, that is x is equal to a cos omega t minus phi. It means you can write displacement like this too. Okay, in terms of x, in terms of y. Whether you take sine or cos, both are same thing because both are periodic functions. So to represent one, just needs to look at the initial conditions. It will depend on that whether we take sine or cos. Alright, so look at here in the diagram. This is the this origin. Oh, okay, and this is a sine wave. Alright, and this represents amplitude minus a, this is also amplitude. Alright, and the time period is from O to T. The time period we can say capital D, and for half cycle the time period is capital T by 2. Okay, clear? Any doubt here? Any doubt? Now let's talk about amplitude. Think about it, everyone. Here question arises, what is amplitude? Okay, think about it. What is amplitude? So look at here. The maximum displacement on either side of the mean position is called the amplitude of SHM. Okay, so the amplitude in this case, look at here, is A. For example, suppose there is a pendulum and its maximum displacement is going up to here, okay, at this point. then it cannot be go beyond that. Then will be the amplitude. Or if a particle is oscillating from here to here, okay, then whatever the maximum, it is reaching up to here. All right. So the maximum displacement on either side of mean position is called amplitude of SHM. Terms related to SHM. So first is velocity. So the velocity of a particle that executing simple harmonic motion at an instant is defined as the time rate of change of its displacement at that instant. So velocity can be write dy upon dt is equal to v is equal to omega under root a square minus y square. Alright. So upon differentiating this we get v. Okay, and the final expression is this one, where y is displacement and t and a, t is the time and a is the amplitude, omega is the angular velocity. All right. So at the mean position, y is 0. We consider the mean position as 0. So when we put 0 here during the motion, then what will it be? So when we put 0 here, then during its motion, the extreme positions, y equal to plus minus a, okay, and v equal to 0. So velocity, maximum velocity is a omega. Okay, the graph of velocity will look something like this. It was maximum at the mean position. Okay, then become 0. Then when it came in the opposite direction, velocity again become maximum at the mean position. Okay. Next is acceleration. So here how we can calculate acceleration? So when we differentiate velocity with respect to time, you will be get acceleration. So we can say acceleration of particle that executing SHM at an instant is defined as the time rate of change of velocity at that instant. So we can write the acceleration d square y upon dt square equal to a equal to minus omega square into y. Okay. So all these formulas are very important. Firstly, here you need to remember how we can write the displacement of the particle that execute SHM. Then how we can calculate velocity. So differentiate the displacement, you will be get the velocity. Then again you differentiate the velocity, you will be get the acceleration of a particle. Okay. So the acceleration is also variable. So at the mean position, it means y equal to 0. So acceleration equal to 0. And at extreme position, where amplitude is maximum, in that case, acceleration, maximum acceleration will be minus a omega square. Okay, if x changes, then a will also change. This means at the mean position, you can write the maximum acceleration equal to a minus a omega square. So acceleration amplitude a max equal to a omega square. Just as we show the velocity amplitude, similarly this will be the acceleration amplitude. All right. Then comes phase. Phase is that physical quantity which tells about the mean position and direction of motion of any particle at any moment, and it is denoted by symbol phi. So suppose how we can find out the phase. Okay, so suppose we have a wave equation. Okay, y1 equal to a sine omega t plus phi 1. So this one is the wave equation. So here phi 1 is the phase. Okay, and suppose second we have a wave equation y2 equal to a sine omega t plus phi 2. So phi 2 here is the phase. Next is what will be the phase difference. So if two particles perform SHM and their equations are this one, y1 equal to a sine omega t plus phi 1 and y2 equal to a sine omega t plus phi 2. In that case, the phase difference, that is denoted by delta phi, will be equal to omega t plus phi 2 minus omega t plus phi 1. So it will be phi 2 minus phi 1. Okay, so here phi 2 minus phi 1 is the phase difference. Okay, yes or no? Actually, phase shows the position of the particle. Okay, and if we talk about the phase difference, so it will be differentiate the two position. All right, phi 2 minus phi 1. Next is time period. Time period is the time when a particle completes its full oscillation, and the symbol is capital T. So the formula is T equal to 2 pi divided by omega equal to 2 pi under root mod of y divided by mod of a. So it will be 2 pi under root displacement upon acceleration. And next is frequency. So we can say reciprocal of time period known as frequency, or we can say it is defined as the number of oscillations executed by body per second is known as frequency. SI unit of frequency is hertz. All right. Then angular frequency. When we multiply frequency by 2 pi, then omega is equal to 2 pi into nu. Here nu is the frequency. All right. So we can say frequency of a body executing periodic motion is equal to product of frequency of body by factor 2 pi. Oscillations of a spring. So there is a 3 springs and all 3 shows elongation. One shows elongation, second natural position, and third compression. Okay, so it means there is a change in position of the spring. So if the mass is once pulled, so as to stretch the spring and is then released, then the restoring force acts on it, which continuously tries to restore its mean position. Okay, so here look at here, restoring force here F equal to minus kx. Okay, suppose this is the mean position. Okay, this is the natural position is this one. This is the natural position, and if we stretch, there is a suppose there is a elongation like above one. Okay, so if spring will be stretched, so after removing, the restoring force will act here, and then there will be compression. Then after compression, it will be regain its natural position. Okay, so this natural position occurs due to restoring force, that is F equal to minus kx, and k is the force constant and L is the change in length of the spring. And in case of pendulum, the time period is t equal to 2 pi under root m/k. Okay, and frequency equal to reciprocal of time period, so it will be 1 upon 2 pi under root k by m. All right. Next is if the spring is not light, okay, but has a mass ms. So assuming the spring has its own mass. So now we are considering the condition that there is a no mass on this spring, but assume that the mass is attached to it. Then the period will be t equal to 2 pi under root m plus 1 divided by 3 ms divided by k. Okay, where ms is the mass of the spring and k is the force constant. Now if two masses m1 and m2 connected by a spring, these are the cases. Okay, so when two masses m1 and m2 are connected by a spring, are made of oscillate on horizontal surface, then its period will be t equal to 2 pi under root mu k. Okay, now here question arises, what is mu? Tell me, what is mu? Varsha, Karthik, VK? What is mu here? Yes, tell me. Anyone? No, 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 no. Anyone? Look at the our formula. T equal to 2 pi under root m plus 1 by 3 1 divided by 3 ms. Okay, and whole divided by k. So there is a mass. Yes or no? There is a mass. Then in the formula which is having below this, so it will be there is a mu. So what is mu? Think about it. Mu is reduced mass. Okay, so where mu is equal to reduced mass of the system, so mu equal to m1 m2 divided by m1 plus m2. All right. Clear? Now we will discuss about the combination of springs. First we will talk about series combination. After that we will talk about the parallel combination. So suppose we have a two springs. Okay, suppose we have a two springs. Look at here. First spring like this, first this one, and second is this one. Okay, so both spring first and second, when both are end to end connected, this one and this one, and the first spring, the end of the first spring is this and the end of this second spring is this. So when both are connected, it means end to end connection. Yes or no? Look at here, end to end connection. So this type of combination we known as series combination of springs. Okay, and the this one is the first spring, so their spring constant is k1, and this one is the second spring, so their spring constant is k2. All right, when we this is horizontally, when we attach this spring, okay, with a rigid support, and when we there is a there is a mass that is attached vertically. Okay, so this is our system. Okay, so we can say the springs are connected in series. All right. So the effective here the formula to calculate the effective spring constant, or we can say equivalent spring constant Ks. So the formula will be 1 upon Ks is equal to 1 upon K1 plus 1 upon K2. All right. And what is K1, K2? K1 is the spring constant of the first spring and K2 is the spring constant of the second spring. All right. So if we rearrange this, you will be get Ks is equal to K1 K2 divided by K1 plus K2. So this is the series combination of springs. Now we know the formula of the time period, that is T equal to 2 pi under root my K. So here K is equivalent spring constant is Ks. So it will be put here in this formula. Look at here, this one. So it will be Ks T equal to 2 pi under root m divided by Ks, and we know the value of Ks, that is K1 K2 divided by K1 plus K2. So just substitute here and you will be get 2 pi under root m into K1 plus K2 divided by K1 K2. Alright. So if you want to calculate the time period of a spring of a two spring and there is a mass connected, that is m, so the formula will be this one. Okay. Next is a parallel combination of springs. It means what? Look at here. Suppose this is our first spring and this is our second spring, and okay, and this is the rigid support, and the springs are connected, look like this. Okay, both. This look at here, look like this. Okay, and there is a mass attached, and mass is attached. Okay, as shown in the figure. So the there is a two springs K, and their spring constants is K1 and K2 respectively, and both are connected parallelly. So in that case, what will be the equivalent spring constant? So we can say if two springs are connected parallelly, so their equivalent spring constant we can directly add K1 plus K2 plus K3. Yes, if there is a, suppose there is a one more spring at here and all three are connected parallelly, in that case what will the equivalent spring constant? Kp equal to K1 K1 plus K2 plus K3. Now the question is, suppose there is a one more spring, there is a four spring K1 K2 K3 and K4, then what will be the equivalent spring constant? Tell me, anyone? Yes, we can directly add, yes or no? So their spring constant, their equivalent spring constant will be Kp equal to K1 plus K2 plus K3 plus K4. Clear? Now there is a one question for you, for everyone. Please solve this question and listen carefully. The question is that we have a three springs. We have a three springs and their constants is K1, K2 and K3. Okay, and the numerical value of spring constant is 1, 2 and 3. For K1 spring the value is 1, for K2 spring the value is 2, and for K3 spring and value is 3. Okay, and all three springs are connected parallelly, then what will be the equivalent spring constant? Yes, what will be the equivalent spring constant? Tell me. One plus two plus three. All right. So 1 plus 2, 3, or 3 plus 3, 6. So we can say Kp equal to 6. All right. And if we talk about the time period, so it can be calculated as follows: T equal to 2 pi under root m divided by Kp, and we know the value of Kp. If there is a two springs, so Kp should be K1 plus K2. So we can say T equal to 2 pi into under root m divided by K1 plus K2. All right? Yes or no? Clear, everyone? Okay. Now calculate, solve one question. The question is that we have a two spring and their constants are 1 and 2, and both are connected parallelly, and there is a mass attached 1 kg. So in that case, what will be the time period? Yes, you will be use this formula: T equal to 2 pi under root m divided by Kp. Okay, so K1 is 1, K2 is 2, so it Kp equal to 3 and the mass is 1. So 2 pi under root 1 divided by 3. Okay, next is force and energy in SHM. So when an object performs simple harmonic motion, a force always acts on it. Okay, which tries to bring it in mean position, meaning it pulls the object towards the mean position. Only then the SHM possible, otherwise SHM cannot occur. So the equation of motion, we know F force is equal to mass into acceleration. So by substituting the expression A equal to minus omega square x and omega equal to, we know, under root k by m. So just substitute the value. So it will be F equal to minus m omega square into x, or it is also equal to minus kx. Here negative sign shows that the direction of force is always opposite to the direction of displacement. Clear? So these formulas are important for the calculation of the force which is acts on a body during performing SHM. Now energy. If a particle, suppose their mass is small m, and that particle executing simple harmonic motion, okay, and at a displacement x from the mean position, so the particle possesses potential energy and kinetic energy at any displacement x. So the formula to calculate potential energy, U equal to 1 by 2 m omega square kx m omega square x square, which is equal to 1 by 2 kx square, and the kinetic energy 1 by 2 k into a square minus x square. Okay, so we know the total energy. What is that? Sum of the kinetic energy and potential energy. So here we know the potential energy 1 by 2 kx square. Here we know the kinetic energy 1 by 2 k into a square minus x square. So when we add both, you will be get total energy is equal to 1 by 2 m omega square into a square. Okay, and if there is a no friction, okay, so total mechanical energy E equal to k plus u of the system always remains constant even though k and u change. This is very important concept. Okay, if there is absence of friction, energy always remain same or constant. Composition of two SHMs. If we combine two simple harmonic motions, we can in the same direction or a direction perpendicular to each other. Okay, so two different forces are act on the particle which can cause different simple harmonic motions. Then the resultant motion of the particle will be combination of both SHMs. Okay, so here we will use vector sum in addition. The same will be used as here as well. So F1 plus F2 equal to m into d square r divided by dt square. Alright. Here R1 plus R2 equal to R, resultant position of the particle, and m is the mass. This one is dt square. Okay. Okay. Typo mistake here. And R1 is the R position, R1 and R2 the position of the particle under two forces, and x is equal to displacement, so we can add both x1 plus x2, so we can write it is equal to a sin omega t plus beta. All right, clear? Any doubt here? Yes or no? Varsha, Karthik, VK? Any doubt? Okay. So in the equation, x is equal to x1 plus x2, which is equal to a sin omega t plus beta. So we can write it here x1 is a1 sin omega t and x2 is equal to a2 sin omega t plus phi. All right. So we know the value of x1 and x2. So the resultant of a1 and a2 as shown in the diagram can be calculated using the formula of the resultant force. So a equal to under root a1 square plus 2a1 a2 cos phi plus a2 square. Here phi is the angle between the vectors. And for calculating angle beta, so tan beta equal to a2 sin phi divided by a1 plus a2 cos phi. Okay, so all these are vector additions, and for any value of phi other than 0 or pi, resultant amplitude is between lie between mod of a1 minus a2 is equal to mod of a1 minus a2 and a1 plus a2. All right. So when two SHMs are mutually perpendicular to each other, so we can say the resultant SHM is given by x square upon a1 square plus y square upon a2 square minus 2xy cos phi divided by a1 a2, which is equal to sine square phi. So it will form like ellipse. Okay, where x is equal to a1 sin omega t and y equal to a2 sin omega t plus phi. All right. So in the equation, x is equal to a1 sin omega t and y equal to a2 sin omega t plus phi. X is always between minus a1 to plus a1 and y is always between minus a2 to plus a2. So there are some special cases of composition of two SHMs. When phi equal to 0, then y equal to a2x upon a1. All right. And when phi equal to pi, y equal to minus a2 upon a1 into x, and this is the graphical representation. And you need to remember these formulas for the exam for calculation numericals. When phi equal to pi by 2, if a1 equal to a2 equal to a, then equation is x square upon a1 square plus y square upon a2 square is equal to 1 will become. Okay. So it looks like a circle. X square plus y equal to a square. Okay, this is the equation of circle. All right. Now To calculate the time period of simple pendulum, we have the formula, and T equal to 2 pi under root L by G. Okay, and the frequency of the time period, reciprocal of frequency of the pendulum, reciprocal of time period. Okay, so mu equal to 1 upon 2 pi under root G by L. And if a pendulum of length L at temperature theta degree Celsius has a time period T, then on increasing the temperature by delta theta degree Celsius, the time period changes to a delta T by T equal to 1 by 2 alpha into delta theta. Where alpha is the temperature coefficient of expansion of the spring. So these are the formulas that we already discussed in detail in previous lectures. So you need to just remember these. Okay. And a second pendulum is a pendulum whose time period is 2 seconds at a place where G equal to 9.8 meter per second square. And the length of the second pendulum is 0.9929 meter, approx 1 meter. And there is a some more time period formulas for different cases. If the bob of a pendulum having density rho is made to oscillate in a non-viscous fluid of density sigma, then it can be shown that the new period is T equal to 2 pi under root L divided by G into 1 minus rho sigma upon rho. And if a pendulum is in a lift or in some other carriage moving vertically with acceleration A, then the effective value of acceleration due to gravity becomes G plus minus A, and hence the time period will be T equal to 2 pi under root L divided by G plus minus A. Here the positive sign is taken for upward acceleration, accelerated motion, and negative sign is taken for a downward accelerated motion. Alright everyone. Now, if a pendulum is made to oscillate in a free falling lift or an orbiting satellite, then the effective value of G is 0, and hence the time period of the pendulum will be infinity, and therefore pendulum will not oscillate at all. Alright. Now, if the pendulum bob of mass small m has a charge q and oscillating in electrical field E, then the time period will be T equal to 2 pi under root L divided by G plus minus QE divided by M. And the positive sign is used if the electrical force is actually vertically downwards, and the negative sign if the electrical force is acting vertically upwards. Okay. And if the pendulum of charge q is oscillating in an electric field E horizontally, then time period will be 2 pi into under root L divided by we can say under root G square plus Q square E square upon M square. So if the next formula is, if the length of a simple pendulum is increased to such an external such an extent, okay, that L approaches infinity. So in that case, the time period is determined by the Earth's radius r, and the acceleration due to gravity is g here. So the formula will be T equal to 2 pi under root r by g. All right. So in the equation, we know the formula time period, that is T equal to 2 pi under root r by divided by g, where r is the radius of the Earth. So there is some graphs, LT graph and LT square intersect. Okay, so there is a two. First is LT square and second is LT on y axis versus x. Here y this curve region is for LT square and LT. Okay, when at t equal to 1 second, both are intersect, and the graph between t square and 1 by g is like a straight line. All right. And the graph between t square and g is a rectangular hyperbola. Therefore, it is important for you to remember all these graphs. All right. Clear everyone? Any doubt here? So you need to just remember all these formulas. Thank you for your attention. Now we will solve some practice questions on these concepts and formulas. So I think, are you ready? Yes or no? You are ready for the practice questions? Okay. Now we will solve practice questions. Hello students. Now we will solve some practice questions based on oscillations. This is our disclaimer. So here we will solve some practice questions based on oscillations. So the first question, the displacement of a particle uh, is represented by the equation y equal to 3 cos pi by 4 minus 2 omega t. Okay. The motion of the particle is what? Here we need to determine the nature of the particle's motion. So we need to explain how the particle's motion will be. Alright. So the given options: option A, simple harmonic with period 2 pi by omega. Option B, simple harmonic with period pi by omega. Option C, periodic but not simple harmonic. And option D, non-periodic. Okay. So which one is correct? Please try to solve this question, everyone. After that, we will provide the solution of this question. Okay. Please solve. And tell me the which option is correct. A, B, C or D. Everyone. Varsha, VK, Kushi. Which one correct? So here, firstly, you need to compare this equation with standard equation. So when we comparing it, you will be get the some values like phase difference, amplitude. Okay. So please solve. Which one correct? A, B. Okay. So the correct option is B. Okay. Let's see the solution. So let's look at the look the given equation. So we have y equal to 3 cos pi by 4 minus 2 omega t. Okay. And let this is equation first. So this is displacement of a particle. So when we differentiate with respect to time of this equation, you will be get velocity. We know the velocity v equal to dy upon dt. So just differentiate equation first. So when we differentiate equation first, you will be get v equal to 3 into 2 omega sine pi by 4 minus 2 omega t. Okay. I think you know the differentiation. And if we again differentiate v with respect to time, you will be get acceleration. Because we know the formula of acceleration, dv upon dt, rate of change of velocity with respect to time. Okay. So just put the value of v and differentiate. You will be get acceleration. So acceleration will be a equal to minus 4 omega square into 3 cos pi by 4 minus 2 omega t. Alright. So when we rearranging the terms, you will be get acceleration is equal to minus 4 omega square into y. So from these calculations, we have a acceleration, we have a velocity. Okay. Now from the formula of the acceleration, it is clear that acceleration is directly proportional to y, and negative sign shows that it is directed towards the equilibrium, okay, or mean position. So we can say particles will execute simple harmonic motion. So it is confirmed from this statement, particle execute SHM. So now comparing the equation, the given equation with standard equation, suppose we have a y equal to r cos phi minus omega prime t. So when we compare both equation, okay, uh, this equation, this one, and this equation, so you will be get omega prime is equal to 2 omega and 2 pi upon t prime equal to 2 omega. So we can say t prime equal to pi by omega. Okay, so we can say B option is correct. Okay everyone, clear? Yes or no? All right, now let's move towards the next question. The displacement of a particle is represented by the equation. So we have a equation y equal to y equal to sine cube omega t. Okay, the motion is what? So now we need to determine which type of motion is non-periodic, periodic. Okay, so there is some options. Option A, non-periodic. Option B, periodic but not simple harmonic motion. Option C, simple harmonic with period 2 pi by omega. And option D, simple harmonic with period pi by omega. Okay, so which one is correct? Please try to solve this question everyone. Yes, please solve. Now I am expecting you are solving this question. Okay, so please solve. Yes, which one is correct? Okay, so to solve this question, firstly you need to simplify this expression y equal to sine cube omega t. All right, by using the trigonometry identity. Correct option is B. Okay. Let's see the solution. So the given equation of motion, we know that is y equal to sine cube omega t. So first we will solve, we will simplify this expression. So we know the trigonometry identity, sine theta equal to 3 sine theta minus 4 sine cube theta. Okay. So look at here, we have a sine cube omega t and here sine cube theta. So here theta is equal to omega t. So we can express this identity in terms of sine cube. So when we expressing these terms, you will be get y equal to 3 sine omega t minus sine omega t and divided by 4. Now we know the displacement equation in simple term. So to calculate the velocity, differentiate it with respect to time. So first you differentiate this term, okay, this term, after that this term. So dy upon dt is equal to differentiation of 3 sine omega t with respect to time minus differentiation of 3 sine 3 omega t with respect to time and divided by 4. Okay. So when we take the differentiation, you will be get 4 dy upon dt is equal to 3 omega cos omega t minus 3 omega cos omega t. Alright. So 4 into d square y upon dt square equal to minus 3 omega square sin omega t plus 9 omega square sin 3 omega t. This terms comes here when we differentiate the above expression again with respect to time. So when we again differentiate it, you will be get acceleration d square y upon dt square. It means d square y upon dt square equal to, this is the acceleration, which is equal to minus 3 omega square sin omega t minus 9 omega square sin 3 omega t divided by 4. So from this expression we can conclude that d square y upon dt square is not proportional to y. Okay. So the motion is not SHM. Alright. As the expression is involving sine function, hence it will be periodic. Next question. Motion of an oscillating liquid column in U-tube is given options. Option A, periodic but not simple harmonic. Option B, non-periodic. Option C, simple harmonic and time period is independent of the density of the liquid. And option D, simple harmonic and time period is directly proportional to the density of the liquid. Okay. So in this question, we need to discuss the motion of an oscillating liquid column in a U-tube. Alright. Please solve this question, everyone. You have some time. After that, we will provide the solution of this question. Okay. Please solve. So the correct option is option C. So the motion of an oscillating liquid column in U-tube like this. Okay. here U2 is liquid in a U2 is a simple harmonic, and the time period is independent of the density of the liquid. All right, so it oscillates like this when up, and then like this upward direction, and below, and then here it's look like this. Okay, so to calculate the time period, T equal to 2 pi under root h by g. So here h is the height of the liquid column. All right, next question. The relation between acceleration and displacement of four particles are given below. Which one of the particle is executing simple harmonic motion? Uh, in this question, the relation between acceleration and displacement for four particles is given. Okay, below, and we need to find out which particle among these is not performing SHM, simple harmonic motion, or rather which particle among these is performing SHM, simple harmonic motion. So there is a four options. Option A, Ax is equal to plus 2x. Option B, Ax is equal to plus 2x square. And option C, Ax is equal to minus 2x square. And option D, Ax is equal to minus 2x. So which option is correct? A, B, C or D? Please try to solve this question, everyone. You have some time. Please solve. Which one is correct? A, B, C or D? So the correct option is D. Okay. So let's see the solution. Wait a minute. All right. So for the motion to be SHM, simple harmonic motion, acceleration of the particle must be proportional to negative of displacement. Okay. So look at here. Suppose this is the mean position. Okay, and when we stretched the spring and then remove, so it will be oscillate like this from the mean position. Okay, so we can say acceleration is directly proportional to minus of displacement. So the relationship between acceleration and displacement must be linear. All right, everyone. Next one, a wave uh, traveling along the x-axis is described by the equation y of xt is equal to 0.005 cos alpha x minus beta t if the wavelength and the time period of the wave are 0.08 meter and 2.0 second respectively. then alpha and beta is in appropriate units are what? So here you have to find out the alpha and beta. All right, please try to solve this question, everyone. Which one is correct, A, B, C or D? Let's see the solution. So A option is correct. So as we know, the given equation is y equal to 0.005 cos alpha x minus beta t. So comparing the equation with the standard form, you will be get y equal to a cos x divided by lambda minus t divided by t into 2 pi. So 2 pi divided by lambda equal to alpha and 2 pi upon t equal to beta. So alpha should be 25.00 pi and beta should be pi. All right. So this is the value of alpha and beta. Okay, everyone. That's all for the today. Thank you for your attention. In next lecture, we will discuss waves. All right. Thank you.